Hi, so in this video we are going to see what are the things that we are going to learn inside this course. So let's start. So the first thing that we are going to learn inside this course is why testing of smart contract is necessary or why testing of a smart contract is important. Because I think the first thing to understand before starting any course is the question why. Why actually we are doing this. So we are going to start with this why. Then we are going to learn about the two most important blockchain developer tools that are Truffle and Hardhat. Using Truffle and Hardhat, we are going to learn how to test a smart contract, how to compile a smart contract, how to migrate a smart contract. So we are going to learn everything about Truffle and Hardhat. And then we are going to learn about the different ways of testing. We can test our smart contract using JavaScript. We can test our smart contract using Solidity. So we are going to see the different ways of how we can test our smart contract. And in order to understand testing in a better way, we are going to take 10 plus smart contracts and we are going to perform testing on those smart contracts. And these smart contracts will be of different nature so that we can understand how to test a smart contract when there is a constructor involved, how to test a smart contract when there is a loop involved, how to test a smart contract when there is a conditional involved, or how to test a smart contract when there is a payable function involved. So we are going to take 10 different smart contracts, 10 different varieties of smart contract, and we are going to learn everything about smart contract testing from basic to advanced level. And this is not it. We are also going to take some projects, some Solidity projects to test them so that we can have a better overview how to test a Solidity project. So this course is a complete package of learning about testing of smart contract. In this course, you are going to learn A to Z about everything, how to test a smart contract, how to perform a successful testing of a smart contract, and what are the things that to remember while you are testing a smart contract. And for your practice, there are going to be labs so that you can also perform testing of a smart contract by yourself. So you are also learning not just by watching videos, but also practicing those things by doing labs. So now let us start this course and meet you soon in the course. Bye bye. Hi. So in this video, we are going to see about the course prerequisites. So the first prerequisite of this course is blockchain technology. You need to have a basic overview about blockchain technology, like what is blockchain technology, how blockchain works, all those things you must know before taking this course. The second prerequisite of this course is Solidity programming language. You must know Solidity programming language before taking this course because I'm not going to teach you Solidity in this course. Okay, so you must know about Solidity programming language before taking this course. You can also take my course to learn about blockchain and Solidity that is available on Codam. I will show you that. Third prerequisite of this course is JavaScript. You must know JavaScript before taking this course. I'm not going to teach JavaScript in this course because we are going to test our smart contract using JavaScript. So definitely you must know JavaScript and especially about the ES6 syntaxes. So you need to know about JavaScript before taking this. So in order to learn about blockchain and Solidity, you can take my course that is Learn Solidity. So here you can see that I have covered everything about blockchain as well as Solidity. So you can take this course to start with the testing of a smart contract course. And to learn JavaScript, you can take this Learn JavaScript Basics course. So in this, Mehul has talked about everything about introduction to JavaScript, about the modern ES6 syntax that you need to learn before taking testing of a smart contract course. So you can take this course also to learn about JavaScript before taking the Solidity testing of a smart contract course. Hi, so in this video we are going to see why testing of a smart contract is essential. But before talking about smart contract testing, let's talk about why do we need to test any software or any program. So we need to test any software or any program because of the following reasons. First, to point out defects. Second, to increase reliability of our software or program. Third, to avoid extra cost. And fourth, to gain client trust. So these are some of the reasons for which we need to test our program or software before deploying it to a live server. Okay. And all these things also applies to our smart contract testing because the smart contract is nothing but it is also a program, right? A program that is written on an Ethereum blockchain. But what makes smart contract testing different from any other testing of any other program or software is that once you deploy your smart contract on an Ethereum blockchain, you cannot make changes to your smart contract. Yes, because blockchain is a distributed immutable ledger. Means once anything is written on the blockchain, on the top of the blockchain, you cannot make changes to that thing. Just imagine a situation where you deployed a smart contract which is not properly tested, which has a lot of bugs. in that situation, you cannot do anything once it is deployed to the blockchain because blockchain is immutable. Plus, you or your company can suffer from a thousands of amount of dollars. And this is one of the most important thing to notice because once any other program or software, let's say your React.js application or your Node.js application, means any other software or application is deployed to a live server, you can make changes to it. But you cannot make changes to your smart contract. Means if you have done any mistake to your smart contract and it is live on blockchain, you cannot make changes to it. So this is what makes smart contract testing very essential. And for this field only, you will see a lot of job opportunities. Means people are hiring those people who know how to properly test a smart contract. So that's why smart contract testing is very essential. First, it helps us to make reliable smart contracts. Second, it provides you with a lot of job opportunity. So these are the two reasons for which you must know how to test a smart contract. First, to make reliable smart contracts, and second, to grab the job opportunities that are present in the marketplace. What is Truffle? Truffle is a tool that helps us to develop, compile, test, and deploy our smart contract on our development environment. Now, what do I mean by on our development environment? Means on our system, we can easily develop, compile, test, and deploy our smart contract. And we are going to see all of these, like how to develop, how to compile, how to test, how to deploy our smart contract using Truffle. Now, in this video, what I want you to remember is that Truffle is just a tool. Remember this point, that Truffle is a tool. That's why I've highlighted this point. Now, why I am stressing on this point is because as you will progress in this course, you will find some new terminologies like Ganache, some new terms. So I do not want you to confuse at that point of time. So I want you to remember this, that Truffle is just a tool like any other tool. Like we also have Hard Hat, with the help of which we can also develop, compile and test and deploy our smart contract. So Truffle is just a tool. Remember this point. Okay. Now you must be wondering, like, what is the use of Truffle? Like we can do all these things like develop, compile, test and deploy. Everything can be done with the help of our Remix ID. So why are we using Truffle? So let me give you two main reasons of why to use Truffle. First reason, easy front-end integration. Suppose in future you want to make a decentralized application. In order to make a decentralized application, you have to integrate your smart contract with some front-end, right? And this front-end can be in any language, like in React.js, in JavaScript, AngularJS, any programming language, any framework or any library, right? Now, in order to integrate these two so that you can make a decentralized application, you need something, and that is Truffle. Truffle makes front-end integration very easy in case of decentralized application. So that's the first reason that why we should use Truffle. Second reason, everything at one place. Now, in order to make a decentralized application, you need to code both in JavaScript as well as in Solidity, right? And if you are using Remix ID, so in our Remix ID, we can only write our Solidity code. So in order to make a decentralized application, we have to constantly keep on switching between our Remix ID and the coding editor that we are using to write our JavaScript code or our React.js or AngularJS code. And as a developer, it is a very hectic process, right? We do not want to do that. Now, with the help of Truffle, Truffle provides us with an environment where we can write everything at one place. With the help of Truffle, we can use any code editor to write both our Solidity code plus our JavaScript code to make our decentralized application. So that's the beauty of Truffle. Like it makes the work of developer very easy. And that's why we use Truffle. Definitely there are various other reasons of using Truffle, but these are the two main reasons of using Truffle. So I hope you like this video. Meet you soon in the next video. Hi. So in this video, we are going to talk about Ganache. What is Ganache? Ganache is a local blockchain simulator with the help of which you can run a local blockchain on your system. But why do we need to run a local blockchain on our system? And the reason for this is to test our smart contract. Let's say you developed a smart contract and now you want to test that smart contract. So you can use Ganache in that particular case, because if you deploy your smart contract directly on mainnet before testing it or to test it on mainnet, in that case you have to pay in real ether. That will be a very costly affair. Like just to test your smart contract, you have to pay in real ether. So Ganache provides you with a facility that you can test your smart contract absolutely free of cost. And our Ganache looks something like this. So this is our Ganache. Here you can see that Ganache is providing us with some addresses, like there are I think 10 addresses, and each account has a balance of 100 ethers. All these are fake ethers, do not confuse it with real ether. All these are fake ethers just to test your smart contract. And when you deploy your smart contract on Ganache, your deployment can be seen on this page, like on this blocks tab. Here you can see all your transactions. Here you can see your contracts, your events, your logs, everything associated with your smart contract is actually shown in your Ganache. And here you have your gas price, your gas limit, hard fork, network ID, the RPC server, and binding status. So Ganache is something that makes the work of a developer very easy. Like you do not have to pay anything like in terms of real ether. So just to test your smart contract, you can use Ganache and you are good to go. And we are going to see how to deploy a smart contract on Ganache. So just have some patience. We are going to see a practical demonstration how to deploy a smart contract Ganache, how it looks, how actually all these things works. We are going to see all of these things. So just have some patience. Meet you soon in the next video. Now in order to use Truffle, we need to install node.js into our system. So just click on node, like we are on a website nodejs.org, and just choose, like I am using Windows, so I'm going to click on this Windows installer. If you are a Mac OS user, click on Mac OS installer, and this is for, I think, for Ubuntu users. So I am using Windows, so I'm clicking on Windows. So I have to wait for some time. So it is a very simple process, and if you already have node.js into your system, you do not need to install it. You can skip to the Truffle installation part. Okay, so this is our dialog box and it is saying to wait. So we have to wait for some time. And now just click on next. I accept the terms of using this. So just click on this, next, next, again next. It is a simple process as I told you. So what is saying that some npm only used to compile for even installing. If you want to able to install such modules, you can install it if you want to. Just click on the next, then click on install, and now the installation process has begun. But I did not need to install it because I already have node.js into my system, and I can show you that. So I am canceling here, but you do not need to cancel it here. Okay, so I can show you that already have node.js into my system. I have to go to my command prompt, simply run node -v. So if you have already installed node.js, or if you are installing node.js, just to check whether node.js has installed into your system or not, just type this into your command prompt, node-v, and click on it. And here you can see that we have our version v14.717.2. So this shows that node.js is already installed into my system. Okay, now let us install Truffle, and I assume that you already have installed node.js like from our previous video. So let's install Truffle. So npm install -g and Truffle. Okay, and just press enter, and in some time Truffle will be installed into our system. Out of 5 to 10 minutes, you will see this line, Truffle at the rate of 5.4.24. This line means that Truffle has been successfully installed into your system, and you can check this also using Truffle --version. Simply by typing this, you can see the version of the Truffle that is installed into your system. So here we have our Truffle, that is, okay, we mistaken with Truffle. I think it is Truffle -v. Let's see. Okay, this is also not the right command that I was looking for. So let me write Truffle version, okay, directly. Now let's see. Okay, wonderful. So here you can see that we have Truffle v5.4.24 Solidity version 5, but we are going to change it to 0.8.9. Then we have Node v14. Then we have web3.js version 5.3. So this shows that our Truffle has been successfully installed into our system. So now let us install Ganache to our system. Just click on this, download Windows, and we have to wait for some time, and then we will start the installation process. So here we can see that our Ganache is downloaded. Now let's start the installation process. Okay, so now our Ganache is already installed. Now let me click on launch. So we have to wait for some time. So now our Ganache has started, and if you're not seeing anything here, like here you can see that I have some flaky pan Ethereum. So do not confuse, because this is the project I was working on. So you do not need to worry about this. Just click on this quick start Ethereum, and you will see that your Ganache is ready to work with. So it will take some time, like it is preparing your local blockchain to your system. So just wait for some time. After some time, your Ganache will be absolutely ready. So here our Ganache is absolutely ready. Here you can see the addresses, the balance associated with these addresses, the private key of these addresses. So everything here, and these are all fake addresses. These are all fake ethers. Okay, these are all fake address and fake ethers. Just for the testing purposes, we have all these addresses and ethers. So here we have our blocks, transactions, contracts, events, logs, and here you can see the current block, gas price, gas limit, hard fork, and everything is given on this tab. Okay, and we are going to talk more about Ganache in our upcoming videos. When we talk about Ethereum blockchain, we have two type of network. First is mainnet and another is testnet. Now, what is mainnet? Mainnet, you can think of it as a network of Ethereum nodes which deals with real transactions. Transactions in which real ether is involved. While testnet is the network of Ethereum nodes which deals with fake ethers, where the transactions are not of real value. And the main use of testnet is to test your smart contract and decentralized application before deploying directly on your mainnet. For example, you created a decentralized application and now you want to test whether your decentralized application is working or not, so you can test it on your test network. And the reason for testing on the testnet is that you do not have to buy real ethers, so it is absolutely free of cost. When we talk about mainnet, it is used for actual transaction with value. When we are talking about testnet, it is actually used for testing smart contracts and decentralized applications. Main network ID is 1 and test network ID is 3, 4 or 42. Now what is this? I am going to explain you with the help of a diagram. Just wait for a second. Now what is the example of mainnet? So Ethereum mainnet is the example of mainnet, while testnet we have Rinkibi, Robsten, and there are other test network also. So now let us see what is this mainnet network ID is 1 and test network ID is 3, 4 or 42. Now this is the website where we can find the difference between main network ID is 1 and network ID test network ID is 3, 4 or 42. Now what does that statement mean? We can see from here. This is a very good website. Want to learn more about test network and mainnet. You will come here. You will see that we have a very beautiful diagram. So what actually happened is that whenever you become a node, right? Whenever let's say you want to become a Ethereum node, in that particular case you have two options. Either you can become a part of a main network or you can become a part of a test network. Now if you select the network ID as 1, you become a part of a main network. This new node, and this new node selected an input parameter for network ID 1, so this node becomes a part of this main network. While if you select the network ID is 3, 4 or 42, you become a part of a test network. Now in this case network ID equal to 3 is for Robson test network. Likewise we have 4 or 42 for different test network, like for Rinkibi we have different network ID like that. So I hope this diagram is more than enough to explain you what is this main network and what is this test network. And we can also see this on our MetaMask wallet, and which we are going to talk about in detail in our upcoming videos. For now, let me open my MetaMask wallet. Let me input my password here. So here you can see that I have this much ether, right? I am not that rich, let me tell you. They're all fake ethers. Why? Because you can see that the test network that I have selected is a Robson test network. So these are all fake ethers. These ethers do not have any significance in real world. These are all for testing purposes. And I can also select Ethereum mainnet, and if I will select Ethereum mainnet, you can see I do not have any ether. So do not try to hack my computer or do not try to do anything with my MetaMask wallet, okay? I'm just telling you because you will find nothing. So this is, you can see in MetaMask we have different type of networks: Robson test network, Kevin test network, Rinkibi test network. All these are there just to test your smart contract, your decentralized application before deploying on your Ethereum mainnet. And on this etherscan.io you can find all the latest blocks and all the latest transaction, and all these latest block and all these latest transaction are part of your main network. Okay, these are dealing with real ethers. And on this rinkibi.etherscan.io you can see all the blocks and transaction which are actually happening on your test network, that is on your Rinkibi test network. That's why it is a Rinkibi test net. So meet you soon in the next video. Bye bye. Hi, in this video we are going to talk about how to initialize a truffle project. As you can see, I'm in my Visual Studio Code editor, and I have created one folder, master truffle here. So let me create one more folder inside it. Let me name this as truffle course, truffle course. Okay. And now let me open integrated terminal inside our Visual Studio Code. So here you can see that we are inside our truffle course. And now we are going to write a command truffle init. Now as soon as I will press enter, you will see that some folders will be created inside our truffle course. So now let me press enter here, and you will see that we will have some folder inside our truffle course. And here we have our folders: contracts folder, migrations folder, test folder, and one file truffle config.js. Now let us talk about each of these folders. The first folder that you can see is contracts folder. Inside contracts folder, we will be creating all our Solidity Smart Contract. So Truffle has provided us with some sample smart contract, that is migrations.sol. You can see on your screen. And then we have our migrations folder. Inside our migrations folder, we will be writing the script to deploy our smart contract. Here you can see that Truffle has provided us with some sample script to deploy our migrations.sol smart contract. And we are going to talk about all these things in great detail, so don't worry about it. Then we have our test folder. Inside a test folder, we will be writing the scripts, the code for testing our smart contract. And at last, we have our truffle config.js, that is the configuration file for our truffle tool. So in this truffle config.js, you will be mentioning about the network that you want to use. Like for example, here you can see that we have host this, port number is this, network ID is this, and we are going to change it according to the network that we want to deploy on. Like if you want to deploy on Ganache, then the port will be different, the host will be different. If you want to deploy on our test network, then the host will be different, the port will be different. And we are going to see that in great detail in our upcoming videos. And then here you can see that we also have our compiler version. Like currently you can see that I am using 0.8.10, that is the latest compiler. But in your truffle config.js, it might be different. It might be older, or it might be this only. But if it is older or it is not the same that I'm using, don't worry. We are going to change it when we are going to compile our smart contract. Okay. And here you can see that there are many other things also available, but we are not going to use them all because this is not the part of this course. So you can, if you want, you can remove all these comments if you want, if you do not need them. So that will be perfectly fine. But I will suggest you wait for some time, and we are going to change our truffle config.js in our upcoming videos. Then you can do with me only. Okay. So this is all about this video. Meet you soon in the next video. So now we are going to see how to compile our smart contract using Truffle. So let's start. First of all, we will create one file. Let's say by the name of demo.sol, and this will be our smart contract. And now let us copy the Solidity version as well as the SPDX license number from this contract that is provided by Truffle. Let me paste it here. Okay. Now let us create one contract, and then we are going to compile our contract with the help of Truffle. So let me name this as demo. And now let me create a state variable number and a function to set the value of this number. Let me have uint number, then public, and that's it. And we are going to do what? We are going to set our number variable with this new number. Okay. And then we will create one more function by the name of get to get the value, to get this number value. Public returns, since number is of uint type, so we will write uint and then return number. Okay. So this is our simple smart contract. Okay, there is some issue. What? Why this is red? Okay, there is some issue. Okay, we can make it view also, right? Because we are not changing the state variable, so we can make it view. Okay, so this is our smart contract. And you may notice one thing, that my smart contract is actually highlighted, right? Because I have installed one plugin by the name of Solidity. So first of all, just search for Solidity in your plugin section, and then just click on this Solidity by Juan Blanco, and just install it and enable it. So you will also see that your Solidity code will get highlighted. Okay, so just do that and your Solidity code will get highlighted. Now what we are going to do is we are going to compile a smart contract. So I will write truffle compile, and this truffle compile command will compile all the contracts present in our contracts folder. Okay, so with this just one command, we are going to compile all our contracts that are present in our contracts folder. Now let me press enter. Okay, there is some issue. What is the issue? Let's see. Okay, what is the issue? Okay, I misspelled it. Truffle compile, right? And as soon as our contracts will get compiled, you will see one more folder by the name of build, which will consist of our artifacts. That is the ABI and bytecode of our contract. So let us wait for some time. And here you can see that we have our build folder. And inside our build folder, we have our migrations.json file and demo.json file. In this, we will have our ABI of the contract as well as the bytecode of our contract. If you do not know about ABI and bytecode, let me tell you that whenever you compile your smart contract gets split into two parts. One is the ABI and another one is the bytecode. And here we can search that also. Let me type ABI. Okay, let me go down. So we will must have our API of our contract down there only. Let us search where it is. It's a long file, right? It is ABI. Okay, let me search for ABI all. Let's see. And within this, okay, there is no response because, yeah, now you can see that we have our ABI. And let me search for bytecode. So this is the ABI of our contract. And now let me search for the bytecode. And let's see. So this is our bytecode. Okay. Now if we will go back to our console, you will see that my contract got compiled by Solc 0.8.10, that is this version of Solc compiler. Okay. In your case, it might be that you might be getting an error if your compiler is not new. And in your case, it might be different. It might be old or it might be different than the version that I am using. But you can change it. For changing it, you have to just go to your truffle config.js and just search for compilers. Okay, where it is? So here it is. And just change the compiler version from here. Let's say I want to go for 0.8.9. Okay, 0.8.9. Let me save it and remove the comments also, right? If you have comments like this, so just remove it just by selecting it and using control plus backslash. Okay, so this will remove the comment from here and save it and just go back and just again type truffle compile command. By using upper arrow key, you can again have this truffle compile and just press enter. You will see that truffle config.js file is smart enough. It will automatically install your Solc compiler 0.8.9. So now here you can see that my contract got compiled by using 0.8.9 Solc compiler. Okay, so you can make changes to your compiler by using truffle config.js file. And this is how we compile a contract using truffle. I hope you enjoyed this video. Meet you soon in the next video. So now we are going to see how to deploy a smart contract on our Ganache blockchain. Okay, so now let us open our truffle config.js and just go to our development. And now let us make some changes here. Now here you can see that we have our host as 127.0.0.1 and port as 8545. Now this is the port for our Ganache CLI. But what we are going to use is Ganache UI, that is this. And here you can see that we have the local host as 127.0.0.1, but the port is 7545. Okay. And since we are going to deploy our smart contract on our Ganache UI and not on our Ganache CLI, so we will make port as 7545. Okay. Now let me save it. Now let us close this. And now we will go to our migrations folder. Now our migrations folder consists of the script with the help of which we can deploy our smart contract, right? I told you. So just do one thing. Just copy this file and just paste it here. Okay. And what we are going to do is we are going to rename our copied file to, you can rename it as anything, it's your wish, but it's better to rename it by the name of your contract so that you can remember it. Demo migration. Okay, and let's save it, and let's change the number here. Let's make it 2. And what is the reason for it, I'm going to tell you in just some time. Okay, now what we are going to do is we are going to just, let's go back to our contract. It is our demo contract, right? So we will, so now in this, first of all, we are going to make this capital, demo in capital. Now this is just a convention that you have to follow, right? You can name it as anything, but by the convention we generally go for capitalized letter of our smart contract. So that's why I have named it as demo, but you can name it as anything. That's your wish, but here you have to mention demo only, the name of your contract, that is this. Okay, and then you have to write here demo. Okay, the constant, okay, in which we have our artifact. Artifact is the build artifact that we have created here. Okay, so that's it. Now let us save it, and now let us deploy our smart contract. Now to deploy our smart contract, we have to write truffle migrate dash dash reset. Now what is the significance of reset, I am going to tell you in just some time. So let us first of all wait for our contract to be get deployed to our Ganache UI. Okay, so this deployment process has begun. If you will see, the account currently has 100 ether, right? But after the deployment, you will see that there will be less than 100 ether in this account because you have to pay certain amount of gas fee. Okay, here you can see that means our contract deployment has successfully done. So before migration, here you can see that our contract got compiled first, and then the migration process starts. Then here we have our network name, network ID. Yeah, this is all present in our Ganache, network ID 577. And then we have our block gas limit, that is also I think present in our Ganache. Here it is 6721975, right? And then we have our initial migrations.js file, that is the migration for our migrations.sol smart contract. Okay, so this is the transaction hash, is the block number at which it get deployed, contract address. Okay, this is the block 0, sorry, this is the block 0, this is the block number, this is the block timestamp, and everything is actually present here. Then we have save in migration to chain and the amount of ether that we have to pay as our gas fee. Then we have our demo migration.js, that is the migration file for our demo.sol file. And here we have our block 0, block number 3, so it get deployed to block number 3. Okay, and here we have our total cost, and this is the total deployments. The number of deployments were 2, right? Because first was migrations.sol and another was demo.sol, and then we have our final cost. And we can check this all on our Ganache also. Just go to your Ganache, go for blocks, and here you can see that we have 4 blocks, right? This is the Genesis block, this is always present in our Ganache, but here you can see that we have 4 blocks instead of 2. The reason for this is that Ganache creates block for each contract creation as well as call, so that's the reason. But when it will come to your mainnet, that will not be the case. So here you can see that we have our contract creation, and this is for block number 1, means our migration.sol file got deployed here only. And here we have all the information related to it. This is the transaction data, created contract address, this is the contract address, and this is the sender address. The sender address is the this address, right? This address is the sender address. So by default, whenever you go for truffle migration dash dash reset, always the first account will be the by default account from which the deployment will take place. Okay, and if you want to deploy it from some other account, you have to make some changes to your migration file, which we will see in our upcoming video. And let's go back to our block 3, right? So this is the block number 1, this is our block number 2, and here you can see that this is the contract creation part for our migrations.sol file, and this is the contract call part for our migrations.sol file. Both of them are the same thing. This is the contract address, this is the from address, and here also you can see that this is the same contract address that is present in a block 2. And same goes for our demo.sol. So this is the block number at which it get created. So this is the contract creation part, and this is the contract address. You can click on it. So this is the contract address. This is the address through which this contract get deployed. If you will go back, this is the block number 4, that is for contract call. Okay, and please do not be confused like why we have 4 blocks, why like for each contract do we have separate blocks created. So that's not the case. In case of Ganache we are seeing this, but when it comes to mainnet this is not the case. Okay, so don't be confused. Just see that your contract is getting deployed to your Ganache, and you can see that by going to the block number in which it says that your block got created. Here it was block number 1, right? And here it was block number 3. Okay, and now let us talk about the significance of using this 1 and 2 here. By numbering these files, we tell the truffle which contract we want to deploy first, which contract we want to deploy next. Like in this case, we have one initial migration.js and two demo migration.js, right? So in this case, initial migration.js file means the migrations.sol file will be getting deployed first. And then since this file, this second demo migration.js, the file related to our demo.sol, so this demo.sol will be the contract will be getting deployed second. And why do we do this? We do this because let's say you created a very large decentralized application. So in your large decentralized application, there will be many contracts, and you want that some contracts should be deployed first. And after the deployment of those contracts, only those like the remaining contracts should be getting deployed. So you can decide the order in which you want to deploy your smart contract in that case. That's why we have this numbering 1, 2, 3, 4. And now let's talk about the significance of using dash dash reset. Okay, and to do that, let us take an example. Now let me go below here. Now let us do one thing. Let us write truffle migrate. So this will also deploy your smart contract on your Ganache blockchain. Okay, by using truffle migrate also you can deploy your smart contract on Ganache blockchain. So now let me press enter, and now let's see what will happen. And now here's an important point to notice. According to Truffle, there are no changes made to our smart contract, and that's the thing. It is saying that okay, no deployment needed here because our contract is already deployed on our means on our Ganache, so we do not need to deploy it again. Okay, let me make some changes here. Okay, let's say I want to have here num. Let's say I want to make it okay num, and here num, and here also num. Okay, and let me make it also num, and let me save it. Okay, now let us deploy a smart contract again by using truffle migrate. Let's press enter, and now let's wait. And here is some important thing to notice. According to truffle, our contract is up to date, means there has been no changes made to our smart contract. But that's not the case. We have made number to num, right? So we have actually made some changes to our smart contract, but those changes are actually got unnoticed by our truffle. Now, in order to avoid this issue, because this is a big issue, right? You deployed your smart contract and you made some changes to your smart contract, and now you are trying to deploy it again, but you are according to truffle says, okay, there has been no changes made to your smart contract. So this will create some issue for your decentralized application. So for that, to prevent from this issue, what we do is we write truffle migrate, so that if there are some changes to a smart contract after deployment, those changes are not getting unnoticed by truffle. So now let me press enter, and now let's see. And here you can see that our contract get deployed again because we have made some changes to our smart contract. That's why we write truffle migrate dash dash reset. So that's the reason for using dash dash reset. So I hope you enjoyed this video. This is all in this video. Meet you soon in the next video where we are going to see how to deploy a smart contract on our test network. Hi, in this video we are going to talk about Infura and why do we need it. So let's start. Let's say this is you, okay? This is you, and you want to be the part of this Ethereum network. You want to interact with the nodes, you want to access the blockchain, you want to deploy your smart contract on Ethereum blockchain. So you want to do all these things. So in order to do that, you have to be the part of this Ethereum network. Okay. Now, in order to be the part of this Ethereum network, you need to install a software called Get. And by installing this Get software onto your system, you also become a node. And now you can easily interact with the other nodes. You can access the blockchain. You can deploy your smart contract. But becoming a node is not an easy process because it requires a lot of time and a lot of resources. It requires time because you have to download all the blockchain that are already present in the Ethereum network. First thing. Second thing, you need a lot of space because in order to download this entire blockchain, this like blockchain having thousands of blocks, you need a lot of space. At least 500 GB of SSD is required. Plus, you need an internet connection so that you can be constantly synchronizing with the blockchain. Means as soon as the new blocks are getting added, you need to synchronize with it. So it is not an easy process, right? And this is where Infura comes in between. This Infura act as a middleman so that you can interact with this Ethereum network without becoming a node. And that's why we need Infura. Definitely you need to pay a certain amount of money to Infura because now on behalf of you, they are actually running node and utilizing all their resources. Definitely you need to pay some fees to them. But believe me, it is a much easier process than to start your own node because running your own node 24 into 7 will require electricity bill to be paid. Plus, it will require a lot of maintenance because you are using your laptop and system for running your node constantly for 24 into 7, right? So that's why we need Infura. So in the next video, we are going to see how we are going to use Infura so that we can connect with the blockchain so that we can deploy our smart contract using Infura. So I hope you understood why we need Infura because it makes our work very easy. We do not need to become a node and we can easily interact with the blockchain. We can easily become the part of this Ethereum network without downloading this Get or any other software like Parity to become a node. So see you soon in the next video. Hi. So in this video, we are going to see how to connect Infura with our Truffle so that we can deploy our smart contract to our test network. Okay. So this is our Infura website. You have to sign up for this website so that you can access it. I have already logged in it, so I am visiting my dashboard. So this is my Infura dashboard, and in this we are going to create a new project. You can see that I have already created some projects in the past, but in this we will create a new project and we will select the product as Ethereum. Let me name it as Truffle in this case. And let's create it. Okay, wonderful. Now here you can see that we have this endpoints, right? And with the help of this endpoints, we are going to connect to our test network. So let's say I want to connect to Robson test network. So I will select Robson here. Okay, now you can see that we have some link here. Now we will use this link in our Truffle configuration so that our Truffle get connected to our Infura, and by connecting with Infura, then we will connect to our Robson test network. Okay, and now we will go to our Truffle config.js. In this, we will search for Robson, and here it will be here it is. So just comment it out and then paste the link in this part. Okay, in this new HD wallet provider in which we are passing the mnemonic, which we are going to see what it is, and then the link. Okay, so let me go to our Infura again. Let me paste this Robson Infura link, the HTTPS one, not the WSS one. Just copy it and then paste it here. Okay, now this is done, and now we have to go for this mnemonic part also because you can see that to connect to Robson we need two things, the mnemonic as well as this Robson Infura link. So we will go for our mnemonic and we have to paste our mnemonic up here. Here it is. So first of all, uncomment out this line, the HD wallet provider one, and then we will copy our mnemonic from our MetaMask wallet. So now let us open our MetaMask wallet and let me type my password here. Okay, so now it's open, and remember to connect it with Robson test network only. Okay, just select Robson test network only because we are going to deploy a smart contract on Robson test network, and then go for the settings. In this security and privacy, reveal secret recovery phrase, and do not share this secret recovery phrase with anyone. Okay, because this is something very private. You should not disclose it to anyone. The reason I am doing this because I am demonstrating you how to do this, but you need not to show this to anyone. Okay, so I will click on reveal secret recovery phrase. So it is also saying that do not share this phrase with anyone. So let me type my password again here. Okay, so this is my secret recovery phrase. I will copy it from here. And then we will have our mnemonic here. So let me create a mnemonic. It's mnemonic equal to then double quotes. Inside this, we will have our mnemonic. And now you must be thinking like, why I'm not using this? And the reason for this is because then I have to create a separate file. In that file, I have to paste my mnemonic and then all those things I have to do, which I'm trying to avoid it because I'm trying to just demonstrate you how it all works. But definitely it is a good practice to have your mnemonic in a separate file so that let's say in future you publish your project to GitHub, then nobody can have access to your mnemonic file, right? You can have that file, your secret file in that git ignore part so that nobody can have access to your mnemonic file. Okay, so let me save it. Now let us open our terminal. Okay, and we have to install one more thing, that is this thing. We have to install this. So let me install this. Install, paste it here. Okay, so we have to install it because it is not present by default in our library. Okay, so now it is downloaded. So now we can see that we have actually satisfied all the needs that we need to do. We have in our SD wallet provider the mnemonic as well as the link to our Robson test network. Okay, so now we can deploy a smart contract to the test network. So we will write the command. So to deploy it to Robson, we will write truffle migrate dash dash network and then Robson. Okay, I made some mistake, just a minute. So it should be Robson, not Robstonet, right? Now if you want to deploy it to Rinkyb, then definitely you can choose Rinkyb. Then you have to make changes here, right? So now our deployment of smart contract is, I think this is the compilation process, and then the deployment will start. And then we will see our smart contract over the test network, over the Robson test network. Okay, so it will take some time because test network will take some time to process them down. Now here you can see that started migrations, network name Robson, network ID 3, and our first file, that is this file, has started with the migration, and that's why we have one here, right? Because this file with, like, we have two files here, right? So which file to migrate first will be told by this numbers. So here it has one, so that's why it is migrated first. And here we have this 2, right? So that's why that will be the second file to be get migrated. So let's say if you want to migrate demo migration.js first, so in that case you will number it 1 and then migration file, this initial migration.js file, as 2. Okay, so in this way you can number your smart contract in which order you want to deploy your smart contract. Okay, I think there is some error here. Okay, no issues. Let us do one thing. Instead of waiting for 2 blocks, let's make it 0. Okay, sometimes it troubles us. Let's try to do that, because sometimes these test network are like, they are not working properly, so we have, sometimes we do need to make some changes to our truffle configuration. Let's try this out. It might work this time. In this, actually it was waiting for 2 confirmations, right? So that's why it is 2. That's why it was 2, but now it is 0. So now let's see what will happen. So the migration has again begun. So now here our first migration has been done, I think, successfully. Now you can see that. So now let's wait for the second migration, that is for this demo.sol smart contract to get migrated. So till then we can see that we have some of the information regarding our smart contract, like its transaction hash, the blocks, the contract address, with the help of which we can identify where is our migration file. Okay, so with the help of this contract address, and we will do this, we will go to Robson test network and we will search for this contract and we can find it where it is. Okay, this is the block number, and here we can see that we have our demo migrations.js file. So now our second file, that is demo.sol smart contract, is actually getting migrated. So till then, let us see this. So this is the balance, this is the gas use, how much amount of gas does it take to migrate this smart contract, this is the gas price and all those things. Okay, this is the total cost that we have to pay for this smart contract. Okay, and for our second, so this is our second demo.sol smart contract. So this is the smart contract address, so that we can find it on, like we can search it on our Robson test network. This is the account from which this deployment has been done. And now if you will see, this account is the same account that is present at our MetaMask. So on our MetaMask, we have 0 cross 0 C2, right? And we can see that here also, right? So here we can see that this is the same account from which this smart contract has been deployed, right? And this is the gas price and everything. And this is the total number of deployments too. And this is the final cost. Now let us go to Robson test network and let's see how our smart contract looks like on the test network. So let me copy this smart contract address, and for you it might be different, okay? So we have to go to this robson.etherscan.io. So this is the test network for Robson. And in this, we will paste our smart contract address. Let's search for it. And here we can see our smart contract. Or let us go inside it. Let's see. So now you can see that. So this smart contract has been deployed at 2 minutes ago on Feb 12, 2022. Yes, and this is the block height. So this is the block height of means at which block number it is. So this is the block number. This is the height of this block, and this is the transaction. And here we have the gas and all those things. It's look cool, right? It definitely looks cool. Like when I did it for the first time, I was amazed by this. It looks so nice, right? So this is the hash, parent hash, and so many other things are there. Definitely you can study about each of them in great detail. So this is our smart contract, and this is how it looks on our Robson test network. So I hope you enjoyed this video. Meet you soon in the next video. Hi. So now let's talk about the differences between Ganache and testnet, because Ganache and testnet works like the same, right? And sometimes we have a confusion like why we need Ganache, why we need testnet, why can't we use only Ganache, or why can't we only use testnet? What are the differences between them? So now let's talk about the differences between Ganache and testnet. As we all know that Ganache is a local block simulator, right, which is running on our system. And since it is running on our system only because everyone has their own Ganache, so it is a centralized system, right? It is an example of a centralized system. And when we talk about our test network, which behaves just like our main network, the only difference between test network and main network is that test network uses fake ethers for the testing purposes of our decentralized application, while in mainnet we have to use real ether, right? So testnet is something which is an example of a decentralized system, right? Because they are behaving just like our mainnet. Second difference. Migration time of our smart contract on Ganache is very less as compared to test network. And you have seen this also, right? When we are deploying our smart contract on Ganache, it is taking around 2 to 3 seconds. While when we are deploying our smart contract on our testnet, it took around 10 to 15 seconds or even more. So this is the second difference between Ganache and testnet. So as a developer, Ganache is a very good choice when we want to test our smart contract in a quick way, right? Because it is taking only 2 to 3 seconds, so we can test our functionality of our smart contract in just 2 or 3 seconds instead of waiting for 10 to 15 seconds when deploying a smart contract over a testnet. So that's the benefit of Ganache. And now the third and the last difference. When we talk about Ganache, Ganache is not reliable for final testing of our decentralized application. And the reason for this is because Ganache is a local blockchain that is running on our system. Definitely, it is a good choice when you want to test your smart contract in a quick way. But since it is not behaving just like our main network, so there is a possibility when you are testing your decentralized application on Ganache, it might run, but on your mainnet, it might fail because Ganache doesn't work exactly as your main network. And when we talk about our test network are made in such a way that they behave just like your main network. So when you are testing your smart contract, when you are testing your decentralized application, when you're doing your final testing, so it's a good choice, it's a better choice to test your smart contract on testnet and then deploy over to the mainnet instead of going for Ganache and then to the mainnet. Definitely you can go for Ganache, check it, and then go for test network and then go for your mainnet. You can do this also, but definitely use testnet as the final testing of your smart contract or decentralized application. So I hope this video was helpful to make you understand what are the differences between Ganache and test network and when to use Ganache and when to use test network. So meet you soon in the next video. Bye bye. Hi. When we talk about testing in Truffle by default comes with a framework, a testing framework, which help us to test our smart contract. And that framework is Mocha framework, which we are going to talk about in detail in our upcoming videos. In Truffle, we can do testing in two ways. First way is through JavaScript, and another way is through Solidity. In this course, we are going to focus more on JavaScript than Solidity because when it comes to testing of complex smart contract, in that case, JavaScript is more efficient, is more good than Solidity because Solidity is something new, right? It is a new programming language. On the other hand, JavaScript is something very old and it has a framework called Mocha framework, which helps you to test your smart contract in a much more better way as compared to Solidity. So our focus for this course will be JavaScript. Definitely we are going to talk about Solidity also, but mostly we will focus on JavaScript, then Solidity. Now let us see some of the important points related to testing using JavaScript. Truffle's JavaScript testing framework is built on top of Mocha. And what is Mocha? Mocha is a JavaScript framework to write tests, and which we are going to talk about in more detail when we will start our testing of smart contract. And when we use testing using Truffle, instead of using describe function that is provided by Mocha, what we use is a contract function. And this is what makes Truffle test different from Mocha, this contract function. When we are using pure Mocha, in that case, we are using describe function. But when we are doing Truffle test, when we are testing our smart contract using Truffle, then we use contract function. And I know now you must be thinking like, oh my God, how many things to remember? First, there is truffle, then there is mocha, then we have contract function, describe function, different types of testing. So don't worry, we are going to summarize all of these in one slide. Now let us summarize all of the things that we have seen so far. When we talk about truffle, we can do testing in two different ways. First, using JavaScript, and another using Solidity. And since JavaScript is used for testing more complex smart contract, we are going to talk about JavaScript in this course. So when it comes to testing of smart contract using JavaScript, what we use is a Mocha framework, right? Which help us to test our smart contract. Using Mocha framework, we can do testing in two different ways. First, using describe function, which is actually used by Mocha, like when we are like using completely Mocha, like pure Mocha. In that case, we use describe function. But when we are using truffle testing, we use contract function. And why do we use this contract function? Let's see. The contract function works like this. First, before each contract function is run, our contracts are redeployed to the running Ethereum node, so the tests within it run with a clean contract state. Now, what does this statement means? It simply means that whenever you are testing your smart contract, you want that your updated smart contract get tested, right? You do not want that your old or previous smart contract get tested. Like for example, you have made a smart contract and now you have made some changes into it. So you want that your smart contract with some changes get tested, not your smart contract with the previous like your previous smart contract, right? So what does this statement is saying that our contracts are redeployed to the Ethereum node. So whenever you are making your contract, they are getting redeployed again and again, so that if you have made some changes to your smart contract, those changes can be seen. Those changes can be seen and those changes can be tested. So that's why our contracts get redeployed to the Ethereum node again and again whenever we are testing our smart contract. Second point. The contract function provides a list of accounts made available by Ethereum node, which we can use to write tests. So whenever you are testing your smart contract, you need some more functionalities to it to test your smart contract. And contract function provides you with all those functionalities. Like it provides you with the list of accounts. For example, when you have used Remix ID, right? So in that case, Remix provides you with some accounts addresses. Your MetaMask provides you with some account addresses. Your Ganache provides you with some account addresses so that you can check how your smart contract is behaving. In the same way, when you are testing your smart contract, you also need some accounts addresses so that you can test your smart contract, and which we are going to talk about when we are going to do it practically. Then you will better understand it. For now, just remember it that the contract function provides you a list of accounts so that you can just test your smart contract. Okay, and which we are going to see practically, then you will be understanding this in a more better way. Now here's an important note. Since Truffle uses Mocha under the hood, we can still use describe function to run normal Mocha tests whenever Truffle features are necessary. So whenever you do not require Truffle features like you do not require the list of accounts or some specific things that are related to testing of your smart contract, in that case, you can also use Mocha. And if you are not getting any of these things, like what is actually going on here, so don't worry, have some patience. Once we will start with our testing of a smart contract, once we are going to see the practical approach, you will get each and everything. Till now, it is all theory, but from our upcoming videos, when you will start with the testing of a smart contract, you will understand everything. I hope you enjoyed this video. Meet you soon in the next video. Hi, so let's begin with the testing of our smart contract. I hope you guys are excited. So let's start. So first of all, what we are going to do is we are going to write truffle in it so that we have our truffle folders. And here they are. So we have our contracts, migration, test, and truffle config.js. Okay, in this video, I'm going to do everything from scratch. I'm going to make changes to the truffle config.js to start with the migrations folder and everything from scratch. Okay, but from our upcoming videos, I will have everything in place. So watch this video carefully so that you do not miss out anything, so that when you are testing your smart contract, you know everything like how to do it from scratch. Okay, so first of all, we are going to make changes to our truffle config.js. and we have talked about truffle config.js, right? First of all, we are going to make changes to it. Okay, it has Sol-C compiler 0.8.10, so I'm not going to change it. What I'm going to change it is the development part. Since I'm going to connect it with our Ganache UI, so I'm going to have 7545 here. Okay, so first of all, this. Now let's go to our migrations folder, or before that, let's go to our contracts folder. And we do not need this file, so we can delete it. Just copy this xpdx license one so that we can use it in our new file. Let me delete this file. We do not need it for now. And we will create a new file, and let me name this file hello testing. Hello testing dot sol. Okay, so let me paste the spdx license number here, and let's start with our contract. So before that, we have to write the pragma line also, right? Solidity equal to 0.5.0 less than 0.9. So our first contract will be hello testing, and then we will have our function, and with the help of this function, what we are going to do is we are going to print hello testing, okay, or return hello testing from this function. Public pure returns string memory, okay, and just we are going to return hello hello testing, and we are going to check this function whether it is working right or not. Now let me save it. Okay, so now we have our contract ready, and now let's make changes to this initial migration.js. First of all, we have to write here hello testing, and then artifacts required will be hello testing, right? This is the name of the contract. This name of the contract. It doesn't matter whatever will be the name of this file, but what we are using here is the name of the contract, not the name of the file. So just know this. Let me remove this. So testing, okay, and here will be hello testing. So testing. Let me save it. So our migration file is also ready. Now everything is in place, and now we are going to test this smart contract whether it is working right or not. So we will go to our test folder. We'll remove all of these. So we will have our test folder, and we will start with hello testing. So the name of your contract with a small letter. Okay, this is a convention that you have to follow. So name of the letter, like this is the name of your contract, hello testing. So we have write small h and then testing. Then we will have our JS file. And now we will start with, let me zoom in a little bit. So first of all, we are going to write const hello testing. And in this, we are going to have our artifacts. Artifacts, they are not ready yet. When we will test our smart contract, you will see that artifacts folder will be created, because when we will do truffle test, then the compilation as well as the migration of the contract will take place, and you will see that artifacts, so that our truffle test file know, okay, which contract I have to test for, because in contracts folder we can have many contracts, right? So we have to tell our test file, okay, you have to test this particular contract. So that's why we are requiring its artifact required, and in this we are going to have our hello testing artifact, and this is also the name of the contract only. Okay, when you will compile your smart contract in artifacts folder, there will be the name of your contract, and we are actually requiring it for only. Save it, and now we will start with contract, right? This is the contract function that we talked about, right, in our previous video. So in truffle we are going to use our contract function. Inside it, we are going to name the contract that we are testing for. Since we are testing for hello testing contract, right? So we will name it hello testing. You can name it anything, but since the name of the contract is hello testing, so it's a good practice to name it on the name of your file that you are testing for, so that there will be no confusion. So that's why hello testing, but you can name it anything. You can name it ABC or anything that you want. Hello testing. So hello testing, this is our name of our contract. And then we will have one callback function. This, okay, this is the arrow function. Okay. Now in this, we are going to write our test cases. Since our hello testing.sol is a very simple contract, right? Where we are testing just for this function, right? Whether it is returning hello testing or not, right? If it is returning hello testing, then we are going to pass it. Otherwise, we will fail. So what we are going to do is we are going to start with a it block. We call it a it block. In this, we write our test cases. For example, this we are going to have it. In this, we are going to write the test we are actually doing. So what we are doing is should return hello testing. Okay, since we are testing for that function whether it is returning hello testing or not, so we will write here should return hello testing. And then in this we will have our async function, because we are going to deal with promises. We will have our async function. Okay, let me save it for you and we have a clean structure. Now this is something which is very much common, like which we are going to use everywhere. First of all, you are going to have your contract function, and then you are going to have your test blocks. You can have more than one test blocks, like if you are testing for more than one functions, more than one functionalities, in that case you are going to use more than one it block, okay, and which we are going to see also. But for now we are checking only for this function, that's why we have only one it block. Now in this it block we are going to write our test cases. First of all, we have to deploy our smart contract. So we will write const hello testing, okay, hello testing, and this await hello testing dot deploy. Now with the help of this line, we are going to have an instance of our contract. Okay, so when we are going to write this line, we will have instance of our contract. Now what do I mean by that? Let us understand this. When we have written this const hello testing await hello testing dot deployed, now we have instance of our contract, means now we have hello testing instance inside our hello testing variable, which looks something like this. This is our hello testing, okay, this is our variable, and this variable is actually pointing to this smart contract, which is hello testing.sol. Now with the help of this pointer, like this hello testing, since it's just acting like a pointer, we can use all the functions, all the variables that are present inside our hello testing.sol, and which we are going to see also. So now let me have our const. In this we will have our result. Okay, now as I told you that hello testing is pointing to hello testing.sol file, right? So what I can do is I will write await. And why I'm writing await again and again? Because we are dealing with promises, because this will return us with a promise. That's why I have written await here. And again I am writing await because again we will use this hello testing variable to call this print function, right? This print function that is present in our hello testing.file, hello testing.sol file. Okay, so what I'm doing is I'm actually calling this print function using this hello testing variable, because hello testing is now pointing to this hello testing smart contract. So now we have our contract and now we have our print function, and this print function must have written with something, right? Because we can see that it is returning with hello testing. So it must have written hello testing to this result variable. So it's time to check whether this result variable actually consists of this hello testing or not. Okay, so what we will do is we will write assert. What is this assert? Is that this function will check whether the result is equal to hello testing or not. If it is equal to hello testing, then it will pass it. If it is not equal to hello testing, then it will fail it. We can check this now. So now we have our test file ready. Let me open the terminal, and what we will write here is we will write truffle test. Now as soon as I will click on truffle test, you will see that the compile, okay, I made some error here because I haven't connected my Ganache. Let me open my Ganache. So these are the mistakes that we do, right? So let me open my Ganache. So let us click on quick start. So now our Ganache is ready. So now let us try to do it again. Let's hope there's no error. Truffle test. As soon as I will do this truffle test, you will see that compilation as well as migration of the file will take place. So here the compilation starts. Now you can see that we have, okay, it doesn't show you how it is migrating, but believe me, it is actually migrated. And see this also, and see this, you can see here, right? We have our contract creation and everything. So it also got migrated. We are not actually seeing here, but it's okay. Here you can see that contract name is hello testing, which we have written here, contract hello testing. And now should return hello testing, because in the it block we have should return hello testing. Okay. And now we can see that it is passing. Why it is passing? Because our result consists of hello testing, right? And we are not checking it with hello testing. That's why it passed. But let's say if I have written here hello testing, okay, let me save it. Now let me try to again test it. You will see that it will fail. Okay, again, what is the issue? Oh my god, again my Ganache got closed. Sometimes there are issue with Ganache. But see, again, or it might be that I have closed it. Remember it. Okay, let's try to do it again. Let me triple test it again. Now you will see that it will fail. Reason being, because we in result we have hello testing, but what we are checking it with hello testing. So here you can see that assertion error, unspecified assertion should return hello testing, but it is not actually returning hello testing. So that's the issue, and it is saying 0 passing, 1 failing. Okay, so this was just an introductory lecture to tell you how actually this whole system works. Okay, but from our upcoming videos it will be getting more complicated, like it will be becoming more complex. But this is the basic idea. This is just a idea to tell you like how this contract testing actually works. And what we are using is truffle contract function here, right? This contract function. So I hope you enjoyed this video, and let me do one thing. Let me make it correct so that we can end on a good note. Okay. Okay. So I hope you enjoyed this video. Meet you soon in the next video. Hi. So in the previous video, we have seen how to test our smart contract. We got an overview of how to test our smart contract. And now in this video, we are going to see how to test this smart contract. Okay. So let me tell you what this smart contract do. So we have two functions here. First, a set function, another a get function. This set function is to set the value of this item variable, and this get function to get the value of this item variable. So it is a very simple smart contract. And now let us test this smart contract. Now in order to test this smart contract, we have to go to our test folder. We will create a demo.js file, right? Because the name of our contract is demo.js. And I told you, like, when you are creating a test file, it's better to have a test file by the name of your smart contract, but in small letters, So let me have it. And I have already made changes to our truffle config.js file. Let me show you. Okay. In this video, I'm not going to do it from scratch, as I already told you, right, in the previous video. So here you can see that I have already connected to our Ganache UI. And remember to open your application, right? Open your Ganache. Do not forget to do it, otherwise it will give you an error. Let me close it. And now let me show you that I have already created our migration file also. So it is also ready. So now we are going to go for our testing of file. So first line will be const demo, and then we are going to have our artifacts, right? So that we can know which smart contract we are testing for. Require. In this, we are going to have our demo, and then we are going to have our contract function. Inside this, we will give the name of our contract. So let me name it to demo contract. Okay, you can give it any name, right? ABC, anything. Let me name it ABC for you so that you will also see ABC. Okay, you can name it to anything, and then we will have our function. Inside it, we are going to again have our it block so that we can write our test cases. Okay, now let me have our it block. In this, we can have should set the value of item variable in smart contract. Okay, so this is the statement that you want to print, and then we will have our async function, right, like before, because we are dealing with promises. Now what will be the first step? The first step will be to have our const demo variable. In this, we are going to have our demo dot deployed instance, right? We are going to have our smart contract instance so that we can play with our smart contract. We can call the functions of our smart contract, check the variables of our smart contract. So we can do all of these by having the instance of our smart contract in our demo variable. Now, okay. right? Now we have instance of our smart contract in our demo variable. So we are going to use it. First of all, we are going to write await, then demo dot set, and then we are going to write here great. Now what I'm trying to do here is, let me tell you. So what I'm trying to do here is, since our demo consists of the instance of our smart contract, right? So let me open our demo.sol. So now we have instance of our demo.sol in our demo variable. Now, with the help of this, what we are doing is we are actually calling this set function and we are passing an argument great to our set function. So what we are actually doing is we are actually setting this item variable, and this item variable is then set to this item variable. Means this underscore item variable is actually setting the great value, the great string, this great string to our item. So now our item consists of this great string. So it is just like calling the function. Okay, we are just calling the set function using this demo.set statement. So what we are trying to do is we are just calling this set function and we are passing an argument great into it. Okay, so now our item, this item variable consists of great. This great string will be there in our item variable. Now what we are going to do is we are going to then have our result. Now to have our result, what we are trying to do is we are actually going to call our demo.get function. Now this demo.get function will return us with this great value only, right? Because in this get function you can see that we are actually returning this item variable, and item variable is set to this great string because we have called this great we have called this set function, right, by passing an argument great, right? So now this will return great into our result variable, and now we are going to check it whether it is doing everything right or not. So we are going to have assert. Okay, now in this assert what we are going to do is we are going to check whether the result is equal to great string here. So if this is great, means if the result consists of great, everything is working fine, then the assert function will work and will pass this test block, otherwise it will fail. So now let us check this. Okay, so now let us check for it. So we will do truffle test. Let's see whether everything is working or not. And do not forget that your Ganache should be on in this case, otherwise it will give you an error. Okay, do remember to switch it on. Okay, so the compilation of our contracts has just begun. Let's see. So this contract is ABC because we have named it as ABC, and it is saying pass, right? Now it is passing, means everything is working absolutely fine. And if we will change it to, let's say anything else, let's say ABC. Okay, let's say we want to name it as ABC. Now you will see that it will give you an error, that it will, again the compilation has begun, contract ABC. So here you can see that we have an assertion error, and the reason for this is very simple, because in result variable we have great as a string, right, and we are actually testing it with ABC, so that's why it is an error. And we can set it to anything else also. Let's say if I want to set it to ABC, I can set it. So it is just like calling this set function. There is nothing new into it. And just let me have our truffle test again, so that we are sure that our test file is actually working right or not. So again the compilation has begun and now it is passing. Wonderful. So I hope you enjoyed this video. Meet you soon in the next video. Hi. So in this video we are going to see how we can test an array in Solidity. And this is the program that we are going to test for. So this is a very simple program in which I have defined an array, which is a dynamic array actually. And then we have two functions. First, to insert an element into array. So ID is an element that we are actually inserting into the array. And then we have the length of the array. Okay. So now let's see how we can test this smart contract. So to do that, we are going to go for our test folder and we will name darray.js. Okay. Array.js. And the first line of the code will be again the same one. The first line will be const darray. This we are going to have our artifacts dot acquire, and we are going to have darray, and then we are going to have our contract function and will be darray, and then we will have our function. The first test that we are going to do is it should insert an element in ARR or into an array. We can say into an array ARR, and then we are going to have our async function. Okay, so the first thing will be again D array. We are going to have the instance of our contract await D array dot deployed, and then we are going to have await. Now we are going to call the insert function of the D array contract. So we are going to have D array dot insert, and we are going to insert 10 to our array. So what we are actually trying to do is we are actually calling this function and we are actually inserting 10 into this array. So the first element at 0th index will be 10, right? Okay. And then we are going to have our const element. In this we are going to have our element, and for this we are going to call again our darray function, that is ARR, and by index 0. Now what is this ARR? So in Solidity, whenever you create a public state variable, then in that case Solidity creates a function for you, a getter function for you, so that you can call that state variable, so that you can get the value of that state variable. So in this case also Solidity must have created a ARR function to get the value from this ARR array. Okay, I think you must know this because this is the concept of Solidity, and if you didn't know this, just Google it out, you will find it. Okay, so we are actually calling this ARR function, which is actually created by Solidity, to get the element from the array. So at index 0, you will see that we have element 10, right? We have inserted 10 at the index 0 by calling this insert function, and now we have 10 inside this element variable. Okay, now let us check whether it is right or not. So we are going to write assert, and let me tell you one more thing. Since we are dealing with numbers here, since we are dealing with integers here, right? So we cannot directly do this element equal to 10. Why? Because this will not work. The reason for this is because for truffle it is not a normal integer or a normal number, but it is a big number object, and we can see that also. Let me comment this out, and let me just do one thing. Let me console log this element so that you can see also. Let me save it. Now let me call this truffle test so that we can see what is the element that we have. So now the compilation has begun, and here you can see that we have some bn -0 words. So this is a big number object. Okay, so we cannot directly take this big number object and then equal check it with 10, because 10 is a number and element is a big number object. So in order to check this element with 10, we have to convert it to a number. And how do we do that? We do that by writing to number, and then we save it, and let me now again call this truffle test. Now you will see that we will have 10 when we are consoling log this element dot to number function. Now the compilation has begun, and here you can see that now we have 10. So this 10, this element, which is a big number object, get converted to a number, and now it is ready to check it with 10. So now what we will do is we are going to comment it out so that if you want to see it in future, you can see this. And then we are going to have this element to number. Okay, so that we can check it. So this is our first test block. Now we are going to have another test block, and in this we are going to check should return or should get an element from ARR array. Okay, again we are going to have our async function. Now if you will see that we have just created one test block in order to test this insert function, right? And now we are going to create another test block so that we can check whether the get function, or I should say this ARR function, is working right or not. Okay, now in order to do that, again we are going to have our let d array, because we have to again deploy it so that if there is any change in the state of our contract, we can find it. Okay, our test file can find it. Okay, there is some changes in our state contract, so that's why, not state contract actually, in the state of our contract. So that's why we have to again deploy it Now we again have a deployed instance of a contract, and again we are going to have the array dot insert. And now in order to test whether this get function or this ARR function is working right or not, we are going to again insert an element 20 into it. And when we will insert this element 20 into it, this element 20 will be inserted at the first index. Okay, because at the 0th index we will have our 10, and at again, since we are inserting 20 into it, so it will be at index 1. Okay, and now we are going to have const id, or not id actually, element, and await the array dot arr1, and again we are going to have, now by arr1, because we are actually checking the index value of 1. Okay, index value of 1 of this array, and index value of 1 of this array is 20, right? So again we are going to have a assert, then element, then since we are again dealing with numbers, right, so we have to write two number. Remember this is a very important point. Whenever you are dealing with integers, whenever you are dealing with numbers, you have to convert it to two number, because for truffle it is a big number object, and then we are going to check it whether it is working right or not. Okay, done. So this is our second it block, this is our second test. Now let us again have a test to test this function, this length function. So in order to test this, we are going to again have one more it block. It is should return the length of ARR. Again, we are going to have async. In this, we are going to this. Let again we have to deploy our smart contract. The array await the array dot deployed const length is equal to await, and since we are using this array instance, so we will have length function. Okay, this length function, so we are calling this length function. This will return the length of the array, right, by this arr dot length method. So now we are going to check it. Assert, again, since we are dealing with number, so we have to convert it to, not actually dealing with big number, so we have to convert it to two number, and then we have to check, because 10 and 20, there are two elements into our array, so the length of the array must be 2, right? Now let me save it, and now let us test our smart contract whether it is working, not a smart contract actually, our test file, whether it is working right or not. Clear the console first of all. Okay, now let us test this. Truffle test. The compilation has begun. So we have our D array and all of the tests are passing, right? So we can see that we have 3 tests and 3 tests are passing, and this is 3 passing. This is good, right? This is wonderful. And if we want to check whether it is working right or not, we can make it 100. Then we can again check it. Check it again. So let's see whether it is working right or not. Compilation has begun, and here you can see that one of the tests failed. Only 2 passed, 1 failed, and this is the test that actually failed. Should insert an element into an array ARR. So that's the thing. Okay. But now here you can see that we have a lot of repetition here, right? We are actually repeating this line of code again and again, right? And when we are doing programming, we do not want to repeat this type of code, right? We do not want this repetition of code. So how we can remove this repetition, we are going to see that in our next video. So I hope you enjoyed this video. Meet you soon in the next video. Hi. So in the previous video, we have seen how we can test this smart contract, right? And we created a test file in which we have written this code. But the problem with this code is that we were repeating this line of code, right? Again and again. Let D array await, deployed, then again, then again. So we were repeating this line of code again and again. So how we can avoid this repetition of code? What we can do to avoid this repetition of code? Now, in order to avoid this repetition, what we can use is we can use Mocha hooks. So Mocha provides us with 4 hooks. First is before, after, before each, and after each. Now let us see the use of all these hooks one by one. Okay. So first of all, let's start with before. Before, and before, then we are going to have our function. And in this, let us write console.log. And before is a hook which runs before all the test cases run or before all the test suits run. So I will write here before all the test suits. Now, what do I mean by that? You will understand this when I will compile this, when I will test this actually. So you will see what I am trying to tell you. So this will actually run, this code will run before all these test cases will run. And let us see this also. We have truffle test. Okay. And here you can see the compilation is begin. And here is our code. So here you can see that before all the test suits and then all the test suits actually run. Okay. So this before runs before all the test suits actually run. So what is the use of after? After runs after all the test suits run. That's simple, right? Let me copy this so that we can after, and in this runs after all the test cases or all the test suits runs. Now let us save this. Let us test this. So the compilation has begun, and here we have our before all the test suits, and then we have after all the test suits. So this after hook runs after the test suits, all the test actually has run. Okay, so this is the use of after hook. Now what is the use of before each and after each? So before each, let me write it for you. Before each, and let me comment it out for. So what is the use of before each? So this before each hook will run before each of the test cases. Means before hook, this before each will run before this test case and before this test case. And we can write this also before each test suits. Okay, so let us save it and let us test this also. Truffle test. So the compilation has begun. And now you can see that. So we have 3 before each hook statements. Before each test suit, before this test case, then before each test suits, before this test case, and before each test suits, before this test case. Okay, so I hope you understood what is the use of hooks, and let us see the use of after each also. Okay, and this is also very simple. It runs after each test suits, right? So let me save it for you. And let us check this also. Okay, by now you will be the master in React hooks, not React hooks actually, in this Mocha hooks. So the compilation has begun, and here we have our after each test suit. So before this we have, not before actually, after this we have this test suit, then after this test we have this test suit, not each test suit actually, this Mocha hook, and then we have after this test suit we have this Mocha hook, right? So this is how we use all these hooks in Mocha. Now in our case, we have to use, we can remove all of these, or let me just comment it out so that you can use it afterwards. Okay, so what we are going to use is, we are going to use before hook in our case. So first of all, we are going to have let d array, okay, equal to null, and then we are going to use before hook. Okay, again, this auto suggestion thing really sometimes creates a lot of problem. Okay, and in this, what we are going to use is, since we are going to write await, right? Await darray dot deployed. So we need to have async because we are going to use await this, and in this we are going to have our this statement. Okay, and we can remove these statement from here because now we do not need this. Let me save it. Okay, so now we have our let darray equal to null, Then before this means before all these before all these test cases, we will have this contract deployed. We have this instance of our contract. So now we can test this. Let's check and test this. A full test. The compilation has begun, and now we have our okay. There is some issue here. Cannot read property insert. What is the issue here? Let's see. Let's say first of all we have this darray.insert 10, then we have this element. Okay, it was our mistake. Actually, we didn't assign it to darray, right? So that's why. So darray was null, right? That's why it was an error. There is no error in this, but there was error in our this code, right? So we have darray, and then before like these tests will run, we need to have our instance of our contract in our darray, right? So that was the mistake with what I did actually. So let me have it again. Referral test. Okay, I haven't saved it. 1 minute. Let me save it first of all, right? Now let me have referral test. So the compilation has started, and now we have our contract darray, and here you can see that now we have all our test cases passed, and we haven't repeated a single line of code, right? And by using these hooks. So I hope you enjoyed this video. Meet you soon in the next video. So now let us add one more function to this darray contract, and that function is get all function. So this get all function will return us with the entire array. Okay, so this will return us with the entire array. So if let's say our array consists of 10 and 20, so this will return 10 and 20, the entire array to us. Okay, so let us check whether this function is working right or not. So to do that, what we are going to do is we are going to go for our test file, and now let us make one more it block to test this get all function. Okay, so I will write it, and in this I will write should get all the elements of ARR, and in that we are going to have a sync, and now we will call our get all function. So we will do await array dot get all. Okay, so this will return us with the entire array. So now again, if you will see, this get all function will return us with this ARR array, right? Which is of uint type. And since it is of uint type, for truffle, this will be a big number object array, right? So the truffle will return us with big number object array, and we can see that also. Let me console.log it so that you can see that have our ARR. So the array that we will get will consist of big number object, right? So let me truffle test it. So the compilation has begun, and here if you will see, now this is our array, right? This is our array that we have actually console.log. So here you can see that it is returning us with the array, definitely, but this array is consist of big number objects, right? And why it is? Because for truffle do not think it is as number or integer. For truffle it is a big number object. That's why it is returning us with this big number object. So now we have to convert this big number object to number, right? So first of all, let me comment it out. Now in order to convert this big number object array to a number array, what we are going to do is we are going to map it. So we will write elements. This we will have our array arr dot map. So this is something which is part of JavaScript. I hope you know this. Then we are going to write element. Okay, so we are actually using element, and then we will convert this element to number, right? So this will return us with a number array. Okay, and we can see that also. Let me console.log elements. Okay, so with the help of this map function, what we are trying to do is we are converting this big number array, this big number object array to number array. And let us test this. Truffle test. So the compilation has begun, and now you can see that we will have our array, right? So this is our array 10 and 20. Okay, and this is because of this line. So now let me comment it out, and now what we are going to do is we are going to write our assert. Okay, so assert, and then we have our elements. And now what we are trying to do is we are actually checking our elements with our array, which consists of 10 and 20, right? But you cannot do directly like this, because if you will do directly like this, it will give you an error. To check an entire array, because elements is an array, right, which consists of 10 and 20, and this is also an array which consists of 10 and 20. So you are checking an entire array, right? So for that, what you are going to do is you have to write one more function, that is, or method I will say, deep equal. So this deep equal will help you to actually check this entire array with this entire array. Okay, so we are using this deep equal method to check this elements with this entire array. Let me save it, and let me now again truffle test this. Truffle test. Compilation has begun, and now let's see. Whatever, right? So now it is passing, because now our elements, which consist of 10 and 20, is equal to this 10 and 20, and we are checking this with the help of this deep equal method. And if I will change something, let's say I will change it to 100, and I will save it, and let's say I again test for it, now you will see there will be some failure. Now the compilation is begin, and here you can see that. Okay, so here it is saying that expected 1020 to deep equal to 120, which is actually not equal, right? So that's why it is saying minus 10 plus 100. So this is the difference. Okay, this is the thing that he was expecting, but what is actually getting. So that's the thing. So let us again make it 10. So this is how we check an entire array. So I hope you find this video helpful. Meet you soon in the next video. Hi. So till now we have seen how to deal with variables, functions, arrays while testing of our smart contract, right? Now in this video we are going to see how we can test when our contract consists of a required statement. So this is a simple contract that you can see on your screen. It consists of a function, that is a check function, in which we are actually entering two variables, means two values a and b, and then we are having a variable c inside it, means it is a local variable also, and we are checking with whether a is greater than b. If a is greater than b, in this case it is good, means a is greater than b, then we are going to go for this statement c equal to a, and then we are returning c. So everything is good, right? And if a is not greater than b, in that case we are printing a should be greater than b. So this is a, means this will be printed when this condition will be false, and if this condition is true, then we will go to this and this line. So now let us go to our test folder and create a file, conditionals.js. Now first of all we are going to have our const, and let me increase the size a little bit. Okay, const conditional equal to artifacts dot wire, and then we have our conditional contract. Okay, then we are going to have our contract, and in this we are going to write contract name as conditional, and then our function, then our it block, and in this what we are going to do, we are going to should check whether a is greater than b, right? Then b, then our async function. Okay, so first step will be to have our contract instance conditional await conditional dot deployed, and then we will do what, we will call our await conditional dot check function, right? Because our check function is the one which is actually checking whether a is greater than b or not. And now for instance, let us pass 5 and 4. Okay, means we are passing in a, we are passing 5. So in a we are passing 5, and in b we are passing 4. And since this is true, right, so this is true, so we will return with c, and c will contain a, so we will be returned with 5, right? It is a very simple contract, I believe. So yes, let us have our assert, And in this, we are going to check our result should be equal to 5, right? So our result should be equal to 5 because C will be returning us with 5. Since 5 is greater than 4, 5 will be assigned to C and then we will return C and that is 5. So in result, we will have our 5. So we are checking this result with 5. So now let us see whether it is working or not. And since we are dealing with number, we have to convert this result to number, right? And here I have made some mistake. It should be conditional because the name of our contract is conditional. And now let us check our smart contract. So we will do truffle test. So the compilation is begin. And here we can see that it is perfectly working fine, right? It is passing, right? And this should be the case because since we are passing 5 and 4 and 5 is greater than 4, so 5 is the result and now we are checking it with 5, so that should be the case. But now let us make some changes to our contract. Now let us do one thing. So instead of 5 or 4, let us try to have here 1 and 2. Okay, 1 and 2. Now let's see what will happen in this case. Now in this case, we can see clearly here that 1 is not greater than 2. So since 1 is not greater than 2, in this case, we will be having A should be greater than B statement, right? We will not go to this line or this line since A is not greater than B in this case. So now let's see whether it is working right or not, or what will actually happen when we are going to have this 1 and 2. Let us save this. Let us open our terminal. Let us have our truffle test. Let's see what will happen. And do not worry about this assert statement because we are not going for this line because we will have an error in this line only. And here we can see that. So we have some error here, return error, VM exception while processing transaction, revert A should be greater than P. So here we can see that we have some error here, right, in our contract. And let me do one thing also so that you can be assured that we are never going to this assert statement. So let me have this console.log and in this let me print hi. Okay, let's see that. For clear the console and now let us check this truffle test. So the compilation is begin and now here you can see that. Now again we have this error and you can see that we never went on this line. That's why we haven't have any high in the console. So how we can deal with this situation? And here you can see that there is something above also, that is that 0 passing, 1 failing. Okay, and then we have this error statement that return error, VM exception while processing transaction, revert should be greater than P. So how we can deal with this situation? Now in order to deal with this situation, what we are going to have, we are going to have our try and catch block. So we will remove this and now we are going to have our try block. Since we are actually having some exception, so what we will do is we will place this to line in our try block and then we are going to have our catch block which will catch error for us. And in this catch block, what we are going to do, we are going to have our assert and this assert will be false. The reason being, since here you can see that 1 is not greater than 2 in this case, right? So in this case, this assert will be false and then we are going to have our statement. So let's say we are going to have A should be greater than P. Let us save this. Okay, we should have E here also, right? So that we can catch the exception. And now let us test this smart contract. Let's see what will happen. So for let us clear the console. Let's now check it. So the compilation has begun. This is our contract and here you can see that. So now in this case, what we have done is we have actually cached this error. We have an assertion error where we are actually stating that A should be greater than B. But in the before case, what we are having some error, that we have an error stating that there should be some reverse statement, there should be some VM exception or all these things. But now in this case, what we are doing is we are actually catching this error and we are actually printing the statement that we want to print. That is A should be greater than B. And let's say if this was again 5 and 4. So let's see what will happen. Let's see whether our try block is working right or not. So say shuffle. First of all, let's clear our console. Okay, clear. Now let us test our smart contract. So the compilation has begun. And now you can see that it is passing, right? So now we have a pass result because in this case 5 is greater than 4. So now we have this assert statement. So we do not need this catch block. So that's why we are having should we check whether A is greater than B. So I hope you understand how we deal with require statement. Simply have the statement in the try block which is going to have an exception. Just have that error or that statement, actually not error, that statement inside your try block, and then have a catch block in order to catch the error. Okay, this is the simple case. I hope you enjoyed this video. Meet you soon in the next video. Hi, so in this video we are going to test this smart contract. So it is a very simple smart contract in which you can see that we have the owner of the contract. Then we are setting the owner of the contract using this constructor. Then we have a deposit function, which is actually a payable function so that we can deposit ether to this contract. And then we have a balance of function so that we can check the balance of this contract. Okay, so now let us make our test file. So the first step will be to create the test file, and for that we are going to write wallet.js. So now let's start with const wallet, and then we will request for our artifacts, right? Require. In this we will have our wallet, and now we will have our contract name, and then our function. Okay, function. Okay, and now we will create our wallet variable, right? And then we will create our before hook so that we can deploy our smart contract before hook. This will be async, and then we will have our wallet, and then we will deploy our smart contract. That is wallet dot deployed. This is done. Now we will create our it block. It should set accounts 0 as owner. So what we are doing is we are actually first of all checking this constructor, whether this constructor is actually working right or not. So in order to test this, we are making this it block. So we will write our async, and then we will have our const owner, and then we will write await wallet dot owner. Okay, so we are calling this owner function. Why owner function? Because as I told you before also, right, since this owner variable is a public variable, so we already have a getter function for this owner variable. So that's why I'm calling this owner function. And then we are going to check whether the owner of the contract is equal to accounts 0. Now what is this account 0? Let me tell you. First of all, we will have an argument as accounts here. Okay, so this accounts will consist of the accounts array, which will consist of all the accounts that are present in our Ganache. Okay, so what we are doing is we are actually checking whether the owner of the contract is actually account 0. Now what is this account 0? Now let me go to the migrations folder. Till now we were using this type of migration file, right, where we have a artifact of our contract, and then we have this function which is helping us to deploy our smart contract. Now, if we talk about this smart contract, now this smart contract is a little bit different from the previous smart contract. And the reason for this is because we are using a constructor, and in this constructor, we are passing some values. So if we talk about Solidity, and if we talk about Solidity Smart Contract, so whenever we are using a constructor and whenever we are passing some argument to the constructor, right, before the deployment of the contract, we have to pass those argument to the constructor of the contract. Now in this case, before deploying our smart contract, we have to pass the owner of this smart contract. And how we can do that? We can do that with the help of this migration file. So what we are going to do is we are going to add one more argument, that is accounts, into it, and then we are going to use one of the accounts. We can use any accounts, and in this case we are using account 0, means this account, as the owner of the contract. You can also use this account, just you have to write accounts index 1, but in this case we are using this account as the owner of the contract. So that's why we are passing this one more argument, and then we are using this accounts array here. Okay, and this accounts is actually provided by this truffle only, so we do not have to worry about it. It is automatically provided by truffle, so we do not need to do anything about it. Okay, so just save it, and now we will close this and we will go to our test folder. So I think now this line makes sense. So what we are doing is we are actually passing the owner by calling this owner function, means by using this owner variable. Okay, let me save it first of all, and let me go to the wallet.sol. Let me place it here. So what we are doing is we are actually calling this owner function, means this variable, and we are checking whether the owner variable is equal to the account 0. And in our case, it should be the case, right? Because in our case, we are passing in migration file account 0 as the owner of the contract, right? So that's why it should pass. And if it is not passing, then definitely we are making some mistake in our contract and our contract is not right. Okay, but in our case, it should pass. And now we will have another function, not actually function, another test, that is to check it should deposit ether to wallet, right? So we are checking our deposit function in this case. So we will have our async, and in this we will have our contract. So await. So now we are going to use our wallet contract, and then we are going to call our deposit function, right? In our wallet.sol we have this deposit function, and this deposit function is a payable function. So here you will see a different type of syntax. So what we are doing is we are actually going to use some of new syntaxes, that is we are going to have from accounts, means from which account we want to deposit. So in our case, we are going to deposit from our index 0 account, means from the owner of the contract. This deposit will be done from the owner of the contract, right? And then we will pass the value. Okay, and all these syntaxes are given in web3.js library. Okay, truffle contract library. You can see that all these syntaxes there. I will share the link with you all, so you can see how it all works. But for now, you can simply see that what we are doing is we are actually depositing in this, like we are depositing to our smart contract using this deposit function. And since this deposit function is a payable function, so this is a syntax. You have to remember this syntax whenever you are passing or whenever you are depositing ether to your smart contract. So we are actually passing 100 ether to our smart contract, and from which account? From account 0. We can also change it to account 1 also, but in our case we are using account 0. Okay, and then we will have our balance, so that we can check our balance of our contract. Okay, so we have to check that also, right, whether the deposit has been done or not. So again, we are using web3.eth.getBalance, and all these things, again I will say, it is provided by our truffle. Under the hood we are actually using web3.js library here, and some of the syntaxes of truffle contract library. So here I am doing this. Okay, so what we are doing is we are actually using web3.js library eth module, and in this we are actually using this get balance function. So by this we are actually doing finding or calling for the contract balance. Okay, contract balance, and in this line we are actually depositing 100 ether to our contract. Okay, something like this. And then we are going to do one thing more, that is we are going to check this. To check this, what we are going to do is we are going to write our assert, and in this we are going to have our balance. So balance of a contract should be 100, right? So it should be 100 because account 0 or our owner of the contract has passed 100 ether to our smart contract. So balance of contract should be 0. But if I will do this, it will give us an error. And the reason for this is because whenever we are using this web3.eth.getBalance function, it will return us with string, means the balance of the contract will be returned, but this balance will be in the form of, or the type of balance will be in form of string. So we have to convert this balance to integer, and we can see that also. Okay, let me do a console.log so that you can see that type of balance, and you will see that it is of type string. Okay, and we will have our balance. So since it is of type string, so we will convert it to integer. So in order to do that, we are going to use parse int, and we will convert it to integer. Okay, so we have tested this smart contract, means this function, as well as this function. Okay, let us first of all check this smart contract so that we can see whether these two tests are actually running properly or not. So let me have this truffle test. Let's hope that there is no mistake, and do see that your Grenache is running right. And here we can see that our both test cases passed, and here we can see that it is a form of type of string. So this balance is a type of string, right? That's why we have converted it to parse int, means we have converted this balance to an integer type. Okay, so we can see this by this console.log statement. Now let us make another test case to check this function, this balance of function, right? So in order to do that, again it, and we will have should return balance of wallet. In this we will have our async. This again we will have our const balance await wallet dot balance of function. Okay, so this will give us the balance, and again we are going to check it. To check it, we will have our assert, and in this assert we are again going to change it to int balance, and balance of our contract should be or must be 100, right? Let us save this, and now let us check our smart contract once again. Okay, let us check this again. So the compilation has begun, and now let us see. Wonderful. So here you can see that 3 of our test cases passed, right? So the first test case was to check the owner of the contract. The second test case was to check whether the deposit function, and the third test case to check the balance of the contract. So I hope you get it how it works, and if you haven't, don't worry, because these type of smart contract we are going to test again and again. So just have some patience, because the next video will be again related to this smart contract only. So meet you soon in the next video. Hi. So in the previous video, we have seen how to test this wallet.sol smart contract. And for this, we have created 3 test cases. That is this test case, and then this test case. Now I have added one more function to it, that is this send function. And what is the use of this send function? Now this send function can be used by the owner of the contract to transfer some amount to some other address. So in the first place, in the first argument, we are going to pass the address of the person to whom the owner of the contract want to send some amount. So this too will contain the address of the person to whom this owner wants to send ether to, and this uint amount to tell the amount the owner want to send to this to address. Okay, so if this contract is called by the sender of the smart contract, then we are going to transfer the amount to the person whom we want to send amount to, right? And if this condition is false, if this function is called by some another address, in that case we are going to revert it, and we are going to say that sender is not allowed. And writing this function or writing this if else condition is just same like writing this. So here we have written actually in the terms of if and revert, but actually what we are doing is we are actually writing this statement, that is require message.sender equal to owner, and if this is true then we are going to this line, other we are going to revert it with this line. Okay, I'm writing this syntax so that you are familiar with this syntax also, and you do not get confused how to deal with these type of syntaxes. So let's go and write our test case for this. Okay, so let's start with our it block, and in this we are going to transfer, right? Should transfer ether to another address. Okay, and then we are going to have our async, right? And now we are going to have the balance of the receiver, means before balance, means before the transaction has been done. So this is the before balance of the receiver, and for this we are going to use web3 library eth web3.eth get balance function. Okay, get balance function, and in this we are going to pass accounts and this time we are going to have index 1. So we are actually sending some amount of ether or some amount of tokens or whatever you want to say, this amount, this UINT amount to this address 1 variable or this address 1 account. Means in Ganache we are sending ether to this account. Okay, let us send ether. Okay, now this is the before balance, means when the transaction has not been done, means when the send function is not been called by the owner of the contract. But now we are going to use our wallet smart contract send, and we are going to send to account 1, and let's say we want to send 10 amount to this account 1. Okay, and then we have to tell from which account we want to send. So from, we want to send it from accounts 0, right? Because account 0 is the owner of the contract, and we have discussed this in the previous video, right? We are making account 0 as the owner of the contract. Definitely you can change it, but for in our case we are actually taking accounts 0. Okay, means this address on Ganache. Okay, and for your understanding, let me do one thing. Let me have console.log here so that we can see what is the initial balance of our or before balance of our receiver. Okay, console.log. Here we will have our receiver initial or before. Let me write before balance. Okay, and in this let me have then receiver before balance. Okay, so that we can see that also. And now let us do the next step. Now we will have again a const, but this time we will have our receiver after balance, because we can see that in the previous line we have transferred 10 ether to this accounts 1, right, with the help of this account 0. So account 0 has transferred 10 ether to accounts 1. So there should be an increase of 10 ether in our receiver after balance. So let me have a wait web 3.eth.get balance so that we can get the balance, the same line as before, accounts, and then 1. And let us console.log this also. So let me copy this only. We will, okay, copy, and then we will have our console, and this we will have our after balance. I'm doing this just to demonstrate you. Okay, you do not need to do this to console and all those things. I'm just doing this so that I can make you understand in a better way that what is actually going on, okay, behind the scene. After balance, so we will print the after balance also. So now let us see this, okay, so that we can confirm that whatever we have written is right. So let me open the terminal and let us do truffle test so that we can see that. Let me save it first of all. Truffle test. Definitely the tests are not completed yet, but just to show you like what is actually happening behind the back. So let us do this. So here we can see that our receiver before balance is this amount of way. Actually this is 100 ether only, but converted into way. And this is the after balance, that is this amount of way. Actually I made a mistake when I was writing 10 here, right? So we are not actually transferring ether here, we are actually transferring way. Okay, so most of the transactions are actually done in way only, so I made a mistake, sorry for that. So it is 10 way, not 10 ether. So that's why we have this amount of way plus this amount of way. That's why this amount is so small, right? Means this 10 way is so small, right, comparison to this, and we can see that also. Okay, so here we are on simple unit converter website. Now let me write 100 ether here. So you can see that in 100 ether we have this amount of way, and then we are adding 10 way to this amount because we are transferring 10 way to this amount. That's why we have 1000000 plus means 10. Okay, that's why we have this amount after balance. Okay, so let us continue now, and we can remove all of these things, console.log, because this is point is very much clear, I believe. Okay, now let us do another thing, and that is to calculate the final balance. So we will write another constant, that is the final balance. Now in this, what we are going to do is we are going to convert our receiver after balance in an object. Currently this receiver after balance is in form of a string. Okay, and you can check that by using console.log type of and then receiver after balance. You will see that it is a string, and we cannot perform mathematical operation on a string, right? So that's why we will convert it to an object. Okay, and then we will perform calculation on it, and you will see that we have some methods to perform calculation on objects. Web3 provides us with everything to do calculation for this. So let me first of all convert our receiver after balance to an object, and to do that we are going to use Web3 utils library or method bn, and in this we are going to write receiver after balance. Okay, so this will give us final balance of the receiver in terms of an object. Okay, let me write it down also, object, and then we will have our initial balance, and we will convert our initial balance means the before balance, receiver before balance, into again to an object. So we will write receiver before balance. Okay, so this is also an object, and now we are going to use assert, and in this assert we are going to have final balance dot sub. So this is a function or a method, you can say, and then we are going to write our initial balance. So this will perform subtraction operation on this on these two objects, that is on the final balance and on this initial balance, and then we are going to convert this object, this whole object, into a number. So we will write to number, and then we will compare it with 10, right? Because we have transferred 10 way to this accounts one, right? So before balance was this amount. Let me have this again. So before balance was this amount, and then we are subtracting it from this. So remaining should be 10, right? So that's why we will have 10 as an assertion. And now we can perform a check on it, that we can see whether our function is properly working. Truffle test. So here you can see that should transfer ether to another address also got passed. If we will change this value, let's say we have 100 here, and let us try to do this, you will see that we will encounter an error. And here you can see that we have an error, right? Now let us write one more function to test our require statement, because not a require statement but this if and reverse statement, right? So we are going to test this whether this send function is actually being called by the owner of the contract or someone else. If it is called by someone else, then definitely we are going to print sender is not allowed, and the transfer function should not work, means this send function should not work. So now let us have another it block, and in this we will have should not transfer ether if transaction not sent from the owner. In this we will have our async, and then we will have our try block. Why? Because I hope you remember when we were using require statement, then we use try and catch, because if there is some error, then the catch block will catch that error. So we will write a wait wallet dot send, and then we will have our accounts 1 in which we want to make the transaction, and then let's have 10, and then we will have our account, right, from which we want to transfer. Let's say in our case, to make some mistake, we use 2. Okay, let's see what will happen, and let me have our catch block so that we can catch the error. In this we will have our assert false, because we are in the catch block, means something is wrong, and in this we will have only owner should send the transaction. Let me save it. Now let us test this whether it is working right or not. Truffle test. Let's see, and here we can see that we have some error, and the error is that should not transfer ether if transaction is not sent from the means from this block, and the error is only owner should send a transaction, because we have used accounts 2 to transfer 10 way to this account, right? And that should not be the case, because in wallet.sol we can clearly see that only the owner of the contract can do that. So let us have 0 again here, means the index 0 contract, the owner of the contract, and let us try this again. Let's see whether it is working or not now. Okay, there is some more error into it, that transfer ether to another address. Okay, this is from which, okay, I think there is some issue in our this it block, and why it is that issue. Okay, I think we have made some mistake here, right? We should convert it back to 10. That's why we were having that error. No issues. Now let us try this again. Okay, all 5 test cases of our contract passed, right? So I think we have learned a lot from this smart contract, how to send transactions, how to convert an object into how to convert a string into an object, and how to perform mathematical operations on those objects by using the web3.js libraries functions, right? And definitely I will provide you the link with all these functions that I am using: web3.utils, web3.et. All those things are freely available web3.js documentation. Okay, so I hope you enjoyed this video. Meet you soon in the next video. Hi, so now in this video we are going to see how to test this transfer amount contract. So first of all, we have this address owner, and with the help of this constructor we are actually storing the address of the person or the user who is actually deploying this smart contract in this owner variable. Okay, and then we have this send function, which consists of two arguments, that is this to array and this amount array. Okay, and we can say that it is an array because of this brackets, right? So this is an array, and this send function is actually a payable function, and this also having one modifier, that is this message.sender owner, means only the owner of the contract can call this send function. Now let's see what this send function is actually doing. So first of all, we have this statement which is actually checking whether the to array length is equal to this amount array length, where this to array consists of addresses because this is an address type array, and then we have this amount array which consists of the amount that we are transferring to these addresses. Okay, so this is of uint type. So if this condition is satisfied, then we are going to this loop. And what is this loop is actually doing is this is transferring the ith amount to the ith address. For example, let's say we have in to array, let's say we have address such as 0 cross 00, then we have some address such as 0 cross 01, and then we have some address such as 0 cross 02. Okay, and we have another array that is a amount array. Now this amount array, let's say, has 10, 20. Okay, 10, 20, 10, 20, and 30. So what we are trying to do is we are trying to transfer 10 to this address, 20 to this address, and 30 to this address. Okay, so this is what this send function is doing. This is transferring the ith amount to the ith array address, that is this to array address. So this is what this send function is doing. This is transferring the ith amount to the ith address. Okay, now let us save this and let's go to our test file. So this is our test file, transfer amount.js. Okay, now the first step will be to have the artifacts, right? So first of all, we will have our const transfer amount contract artifacts dot require, and in this we will have our transfer amount smart contract, and then we will have our contract. Let me name this as transfer amount only, transfer amount, and then we will have our accounts array, right? Accounts array, which we have talked earlier also. Now we will create one more variable, that is transfer amount variable. We initially null, then we will have our before. In this we will have our async function, and in this we will deploy our smart contract, that is transfer amount inside our transfer amount variable. Await transfer amount dot deploy. So now we have the instance of our smart contract. Now we will create our first test case, it, and we will have should transfer amount in an async function, and inside this async function, first of all, we are going to have or going to create an array, that is a recipients array, and let me have this array as accounts 1, then accounts 2, and then accounts 3. So what we are trying to do is we have this accounts array, right? We have this accounts array. So we are having this accounts array addresses inside this separate recipients array. Okay, so we are taking the value of accounts 1, accounts 2, and accounts 3 inside this recipient. So we are having this recipients array which consists of this accounts 1, accounts 2, accounts 3, and which we can also see in our Ganache. So this is our accounts 1, accounts 2, and this is our accounts 3. This is our account 0, right? Now we will have an array that will consist of the amounts. Let's say we have 10, 20, and 30. And now we are going to have our initial balance is array, and inside this we are going to have the balance of all our accounts 1, accounts 2, and accounts 3. And for that we are going to use our promise.all. The reason for having this promise.all is because now we are going to deal with a loop. Okay, so recipients recipients, then map. We are going to use our map and then recipient. So this is the syntax that is related to JavaScript. Okay, JavaScript ES6. And now we are going to return web3.eth.get balances. Okay, so this will give the balance of all the accounts that are present inside our recipients array. And we can see that also. Let me print it out so that you can also see this, that in our initial balance, now we have the balances of all our accounts 1, accounts 2 and accounts 3. Initial balances. Okay, let us save this. Let us try to test this so that we can check this statement, this test file actually. Okay, I actually made mistake in our get balance, I believe. Should we get balance? Let us try to test this again. So now here you can see that we have the balances of all our accounts, that is our accounts 1, accounts 2 and accounts 3 inside our initial balances. So this is equivalent to 100 ether, right? Let me go back to Ganache. So we have this 100 ether, 100 ether and 100 ether, right? So that's why. Now let's continue with our test file. So now we will have our await transfer amount dot send function so that we can send some amount to our two addresses. Okay, so now we are calling this send function and we are transferring some amount to these two addresses. Okay, and for that we are going to have two arguments. First is recipients, another one is amounts. So these are the two arrays, this recipients array, this array and then this array. Okay, and then we have to tell from which account we want to call this send function. So for that we are going to have our from, and in from we are going to call our accounts 0, right? So this is the owner of our smart contract and value 90. And why I'm calling this the owner of our smart contract, because in migrations.sol, if you will see the migration.sol file, I have actually deployed this smart contract using this account 0. So that's why account 0 is the owner of this smart contract. Okay, so this is what we are trying to do. And now, and what is this value? Since this send function is a payable function, right? So we need to tell the amount that we want to transfer to this smart contract, as it is a payable smart contract, or actually a payable function. So whatever the value we are going to transfer will be going to transfer to this smart contract, this transfer amount dot solve smart contract. So now we will create one more array, that is a final balances array, which will consist of the balances of the different recipients after the transfer has been taken place. So we will have final balances. Again, we are going to use promise.all recipients.map. This we are now going to return with web3.eth.get balance. Get balance. Then receive it, right? So this will give us an array of final balance of these recipients. Okay, after the transfer has been taken place, means after the transfer, like after 10, 20, 30 has been transferred to these accounts, to these three different accounts, and we can see that also. If we want to print it out, we can see that. So let me console.log this final balance array for you so that you can see that also. Now let us test this. Test. So now here you can see that we have two arrays. First one is our initial balances array, which has 100 ethers. Okay, in each account you can see that we have 100 ethers. In the second array you can see that we have 100 ether plus, means not this 10 way, actually this amount of way plus 10 way. Okay, so this amount of way means this amount, like this amount of way get added 20, this amount of way get added 30, because this is the amount we are actually transferring to these accounts 1, accounts 2, accounts 3, right? 10, 20 and 30. Okay, so this is what we are doing. So let me comment it out. Okay, because we do not require it now. Now what we are going to do is, now we are going to create one more loop, with the help of which we are going to subtract both of these final balances and initial balances array amounts, and then we will compare it with these amounts. Okay, so for that we are going to have recipients dot for each. This time we are going to use for each. In this we are going to have item I, and then we are going to have const final balance. This time let me have const final balance web3 dot utils. Now we are going to convert our final balance array objects, not actually objects, final balances array element into an object. Okay, so I am going to take this ith value. Okay, the ith value will be converted to this final balance object by with the help of this web3.utils.bn. Okay, so we are converting it to an object, big number object, so that we can perform mathematical operation on it. That's why we are converting it to an object. In the same way, we are going to have our initial balance. Again, we are going to convert our initial balance array elements to an object, and then we are going to assert. In this, we are going to have our final balance dot subtract initial balance dot to number. Now we are converting this number, means this object, to a number, and then we are going to compare it with the amounts array that we have declared earlier. Let's save this, and now we can check this whether it is working correct or not. So it's a very simple test case, I believe. So simply we are subtracting the two amounts, and then we are comparing with the amounts I. Means if you will see, like we have these two array, so we are subtracting this amount to this amount, so the remaining will be 10. Subtracting this amount to this amount, the remaining will be 20. Subtracting this amount to this amount, the remaining will be 30. And then we are comparing with the array element amounts I, and if you will see amounts I, you will see that we have 10, 20 and 30. Okay, so it must pass. Okay, we do have some error. What is the error? That authentication assertion response is not defined. Okay, let's see what error we have actually committed here. Okay, by mistake, I believe this got converted to something else. Should be assert. Sorry for that. Truffle test. Wonderful. So now you can see that we have this should transfer amount getting passed. Okay, now let's start with our another test case. So we have created two test cases till now, right? No, only one test case, that is to transfer amount. Now let us create one more test case, and that test case will be, and this test case will be to check whether the array length, that is the two array length and the amount array length, are equal or not. Okay, so should not transfer amount if array length is not the same. Okay, and in this we are going to see some concepts also. Be alert. Okay, async. Okay, so now let us create our recipients array. So it will be accounts 1, accounts 2, and then we will have our accounts 3. Okay, and then we will have our amounts array, const amounts, which will have 10, 20, 10 and 20. Okay, so what we are actually checking for, we are actually checking for an invalid input. Why an invalid input? Because the recipients array is of length 3 and in amounts array is of length 2. So these two array are not of the same length, right? But in our transfer amount dot sol, if you will see, the array length must be same. So that's what we are actually doing. This is what we are actually checking for. We are checking for the wrong or the invalid inputs. So what we will do is we will have our try class block, and try block I will have await, then transfer amount dot send, and in this we will have our recipients array and then our amounts array, and we will do this transaction from accounts 0, and then we will have our value, let's say 10. Okay, now we will have our catch block, and first of all we will learn a concept here because this is something very important that you should know. Now since we have a catch block, right, and if you will see that this try block, means the code inside this try block will actually throw us an error because the array length are not the same, right, which we can clearly see from here, right? So let us catch this error. Let us see what is this error all about. Console.error and e. Okay, so like this we can catch our error. So let us save this. Let us truffle test this. Truffle test. And now let us see what is the error that we are actually catching. Okay, I think we have made some error. Reference accounts is not this. Okay, I think we have made some error. Okay, that's what the issue was about. Now Let's try this again. So now you can see that we have our error. Let's see our error. So this is our error, right? Error, and this error is that return error VM exception while processing transaction revert to must be same length as amount. So where this statement is actually coming from, this statement is actually coming from this require statement, right? That 2 must be same length as amount. So this is our error statement. So what now we are going to do with this statement is, now we are going to use this statement in our assert. So I will write here assert e dot message includes, and then what we will do is we are going to copy this statement 2 must be a same length as amount, and we will paste it here. So what we are trying to do here is, when this send function, means when this try block will throw us an error, means the statement inside this try block will throw us an error, then we are going to catch that error, and then we are going to use this assert, means this statement. So this statement will provide us with either true or false. So this will be true, right? Because this is actually throwing us with an error that is containing this statement 2 must be as same length as amount. So this will definitely be a, means whatever will be inside this assert will be a true thing, right? So we are going to use that as our catch block statement. Okay, then we are going to return from it, because what I'm going to do is I'm going to have a assert, and in this we are going to have false. So if by chance this get passed, so what we will do, we will throw an error. Why we are going to do that? Because this test case, if you will see, this test case is actually meant to test for wrong inputs, right? This input and these two inputs are wrong inputs for this send function. So that's why we are having this assert false. So by chance if it is getting passed, we are going to throw as an error. Otherwise we are going to this catch block, we are going to use this assert, and then we are going to return from here only. So this will not get execute. So this is all the concept of JavaScript only. So now let us try to test this test case whether it is working correct or not. So we will do truffle test. So here you can see that we have this should not transfer amount if array length is not the same, and this should be the case for this test case because the array length are actually not the same, right? So this test case is actually working. And if you haven't understand this test case, just don't worry, we are going to see another test case to understand this in a better way. Now let us make our another test case, and that test case will also be checking for the wrong input only. So it will be should not transfer amount if caller is not the owner. Okay, caller is not the owner, and then we will have our async, and then we will have our cons recipients, then we will have, again let me copy this down only and paste it here, just increase it to 30, because now we are not checking for array length are not the same, right? We are checking for that caller is not the owner. So now again we will have our try block. Again we are going to call, let me copy this down again only, let us copy this whole, okay, and we will make some changes to it. Let us copy this as a whole. Okay, so now what we are going to do is, since we are checking for if caller is not the owner, right? So we are checking for a wrong input, so let us make this as 4. So now we are calling this transfer amount dot send function from this accounts 4, and now let us do one thing. First of all, let us catch this error so that we can see what is the error all about. Let us save this. Let's remove this also. Okay, now let's test this again. Truffle test. Let's see. So again we have an error. Let's see the error. What is this error all about? So now we have an error as returned via error VM exception while processing transaction revert. So this is our error statement, right? So in this case we will copy this statement. We will copy this statement, and now we are going to use this statement inside this assert. So let me comment it out, and now just this out and this out. But this time we are not having any string like this, right? In this error statement, if you will see, we do not have any string related to this, because if you will go back to our previous test case, when you are calling this function, when the array lengths were not the same, then we have this require statement which was actually printing this line. That's why we were able to check this inside this in this catch statement that I said e dot message includes this length of, means 2 must be same length as amount, this one, this statement. But in this case we are going to have this statement as our catch. So if this is true, then this assert will be true, and then we are going to have our error, means have our test case passed. So let me do this again. So now you can see that we have our test case passed. That should not transfer amount if caller is not the owner. So we are actually checking it in a right way. So I hope you understand like how we are actually checking for the wrong values. So here we are actually checking for the wrong values, right? This two statements means these two arrays were of not the same length. So we are checking for wrong input values. And when we have this test case, in this case, we are actually calling this send function from accounts for. So this is also a wrong input value. And then we are actually catching that error. And if you will go above, in this case we were actually not checking for wrong values. Okay, so should transfer amount, so this is a positive statement, so we were not checking for the wrong values. So that's why it is a simple straightforward test case. But in this case, since we were checking for not values, we can do something like this also. I hope you enjoyed this video. Meet you soon in the next video. Hi. So in this video, we are going to see how to test our loan smart contract. First of all, let us see how this loan smart contract is actually working. So first of all, you will see here that we have an NM here, and now we are having a state variable, means we are having a state variable of type NM, right? So we are having a state variable of type NM. I hope you know like how NM works in Solidity. So initially, like we are having our state as state.pending, means this is state, okay? And then we have some state variables here, and then we have this constructor, and we are actually initializing these state variables by using this constructor. So we have the amount, since we are talking about a loan smart contract, right? So there will be a borrower, there will be a lender, there will be an interest, there will be an amount, and there will be a duration, right? This is obvious. Let's say A is lending some money to a borrower, so definitely there will be a interest on that money, right? This is how loan smart contract works. This is how loan actually works, right? So that's why we have the amount that the lender is going to pay, interest on that amount, the duration of that loan. Then we have a borrower, like whom we are actually borrowing that money, and then we have a lender who is actually borrowing, like the person who is actually lending the money to this borrower. When I'm saying money, this is definitely ether, right? And then we have this lend function, which can only be called by the lender of the smart contract. That's why we have this require statement. And then we are actually transferring some, then we are actually checking for whether the address this dot balance, means whether the contract balance is equal to the amount or not. Because if you will see that this function is a payable function, so the lender, whatsoever money the lender is going to lend, he has to pay to the contract. And then we are checking whether the amount that initially we have actually fixed for this, like when initially we have initialized this amount for, then we are checking whether that amount is equal to the address this dot balance, means whether the lender is actually sending the same amount or not. And this is true, then we are going to call this change state function. I'm going to talk about it, don't worry. And if this is like, if this worked properly, then we are going to transfer the amount of money to the borrower address, okay? And then we have this reimburse function, which can only be called by the borrower. In this, you are checking for whether this is called by the borrower of the smart contract or not. And then we have this require statement, which is actually checking whether the message dot value, means the amount that is borrower is actually sending, right? Because again, you will see that this is a payable function. So we are checking whether the message dot value, means the amount that is that the borrower is actually sending back to the lender, whether is equal to the amount plus interest or not, right? Because now borrower has taken some money from the lender, right? So he need to pay some interest on it. So that's why we are checking for that. And then we have this change state function, which we are going to talk about it. And then we have this lender dot transfer, means now we are transferring the amount and plus interest to the lender, okay? And now let's talk about this change state function, like what this change function is, like function is all about. So first of all, we are checking whether whether the state that you are changing for, if you will see that we are actually passing the state, right? Here we are passing change state dot close, means the value that is present in our NM. So we are first of all checking whether the 2 is equal to state dot pending or not. If it is not equal to state dot pending, then definitely we can move further on. Otherwise, we are going to print it that state is already in a pending state. Okay. And then we are checking whether the 2 value is not equal to the state, means what is actually happening is, let me tell you, let's say for example, the lender has called this lend function, okay? So definitely he will call this change state function. So this state dot active will be in the 2 value, and then we are going to pass this value, because change state dot means state dot active is not equal to state dot pending. And in this case also, if you will see, state is initially, you will see initially, is it state dot pending. So in this case, state.active is not equal to state.pending, right? So we are going to pass this required statement. But by chance, let's say this 2 and this state are the same values. By chance, this 2 is equal to state.active and this state is also equal to state.active, because if you will see, we are actually initializing this state, not actually initializing, we are changing the value of this state once this is true, right? So if this happens, we are not going to like pass this require statement. So we are checking for this, and just go through the smart contract, you will understand it. Okay, it is very simple. It is very simple. Okay, so just go through it once, you will understand it what I'm trying to say. And then we have this if statement, which is actually checking whether the 2 value is equal to state.active or not. Let's say the lender has called this function, definitely 2 is equal to state.active, and then we are checking whether the state is equal to state.pending or not. So we are checking that also. Okay, and then we are checking whether the state is equal to state dot, means not actually checking, we are then actually changing the value of the state variable from state.pending to state.active. Okay, and then we have this end, means the duration of this loan, right? Because we have a duration for our loan, right? So that's why what we are doing, like that's what we are trying to do here. So we are actually having the block timestamp, means the time at which this block is created, plus the duration, like the end time of this loan. Okay, so this is how this will work. Okay, when like if the lender call this change state function, but let's say when the borrower will call this reimburse function, in that case 2 will be equal to state dot close, definitely, because here we can see that. And then we are checking whether the state is equal to active or not, means whether the lender has already lent some money to the borrower or not. Because if state is already in pending state, definitely the lender has not lent some money to the borrower. So in that case, definitely we are going to like print this statement that state is not active, or state is not, yeah, state is not active, right? State dot active, state is not active in this case. Then we are checking for whether the block dot timestamp is equal to, is greater than equal to the end time, means the time at which this block is created, whether this is equal to the greater than this end or not. And then we are checking for whether the block dot timestamp, means the time is greater than equal to end or not. So which we have actually initialized here, right? This end, right? So we are checking for that. If it is true, then we are going for this state is equal to state dot close, and then we are going to transfer the amount to the lender. Okay, so this is how this smart contract works. If you're finding it a little bit complicated, don't worry, just go to this smart contract once, you will understand it. It is very easy. Okay, now let me show you the migrations file. So this is our migrations file, and in this you can see that we have this loan contract that we are actually deploying, and then we have our constructor variables that we are initializing, that is the amount, interest, and duration. So this is the amount, 1000 is the amount, this is the interest, and this is the duration, right? And this is the borrower. I think, yeah, it is borrower, right? Yeah, it is borrower, and this one is the lender. So accounts 2 will be the lender and accounts 1 will be the borrower. Okay, and now let's go to our test file. Okay, I should rename this to loan, right? Not load. So in this, first of all, we are going to require some packages. So we will require expect revert. Okay, and since this is smart contract deals with time, right? So we will require this time also. You will understand it how it works. So we'll use our require at open Zeppelin test helpers. If you haven't installed it, just install it. I have already installed it, so I have this package. Otherwise it will give you an error. Then we are going to have our artifacts, and now we will have our contract function. So now let's declare some variable. So we will have loan, we will have some amount. Initially, let's say we have 1000. Okay, const interest, let's have interest 10%. Okay, and then we have some duration, let's say 100. So when we are talking about duration, so in this we are talking in seconds, right? Because if we talk about block dot timestamp, so it deals in Unix time, right? So it is already in seconds. Okay, so that's what I'm trying to say, that this duration is actually in seconds. And now we will have our borrower as well as our lender. In this we will have our accounts 1 and then accounts 2, right, from our Ganache. Now let's have our before function. In this we will have our await loan dot deployed. Okay, so this will contain the instance of our smart contract. Okay, this should be before, right? Before. So now let us write our first test case. That should be that should not expect, except, sorry, not expect, lend if not lender. Okay, So we will call our expect revert, and in this we are going to pass loan dot lend. Means we are calling this lend function from our loan contract. Let's call this function from the borrower side. Okay, so we are actually checking for the not case borrower, and let's have the value as amount. And now we will copy this exact code from this. Okay, just copy this code and we will put it should be inside this, right? Inside our expect reward. Let's save it. Wonderful. So this is for checking whether the lender is calling this function or not. Okay, and now we will have our another test block, and that will check should not accept lend if not should not accept lend amount if not exact amount sent by the lender. Okay, now in this we will have our await expect revert again, and in this we will call this loan dot lend function from our lender point, but we will have an amount that will be the value should be, let's say, if you will see that we have amount as 1000, right? But let's say in this I just put 100 only, so this is not the right amount, right? So it will throw us an error, and if it will throw us an error, then we are going to have our this statement cannot lend the exact amount. So let's print it here. Let's save it. Okay, now before moving further, let us test these test cases whether they are working or not. So we will write truffle and then test. Okay, so we have actually made some mistake, right? Here should be loan, not small, because in loan we have our artifact, right? So that was the mistake. So now let us test this again. I hope this time it will work and I have made any typing mistake. Okay, so again I have actually made some typing mistake. Sorry for that. I know I'm a bad typer. It should be loan, right? Now let us test this again, and this time it will work. Wonderful. So now here you can see that both of the test cases are actually passing. Now let's move further. Now we are going to check for a positive statements, that is should accept the lend amount. Accept the lend amount. Then we will have our async function again. So first of all, let's have the balance, the before balance before, and in this we will call our web3 dot utils dot bn. We are going to convert the balance to an object, right? And we have seen this also, like why we do this, so that we can have a easy subtraction and addition, all those type of things on objects. So we will have our await web3 eth dot get balance, this we will have our borrower, and then we will have our const loan lend. So we are calling our lend function, and in this we are having our from lender, then we are going to have our value and then amount. Here should be wait, right? Oh wait. Okay, so now we are actually calling this lend function from this loan smart contract, and we are transferring some amount to the borrower. So in this case, if you will see that we are actually checking whether what is the initial balance of the borrower, which will be definitely 0, and now we are transferring some amount to the borrower, and now we will check the balance after, and in this we will have our web3 dot utils again dot to bn await 3, should be await web3 dot eth dot get balance, and in this we will again have the borrower's address. And now let's check the state also of our smart contract by calling await loan dot state, right? So we are calling the state variable. Let me show you. We are calling this variable, where it is here. So we are calling this state variable. Okay, so first of all, let's see whether the state dot to number, we are converting it to number, is equal to 1 or not. Because if you will see this loan like lend function, in this we are actually changing our state to state dot active, right? And if we talk about enum, so it is 0, this is 1, and this is 2, right? So that's what we are checking for, whether the state is an active state or not. And then we are going to check the balance after dot subtract balance before, and now we are going to convert it to a number, and now we will check it against the amount, right? So what we are trying to do is, if you will see, So the balance before of our borrower was 0, and now we have transferred this 1000, this amount to our, if you will see, this amount to the borrower, right? So we have transferred this amount, and now the borrower, like the borrowers consist of this 1000, and now we are checking whether this balance after, that is this 1000 minus 0, is equal to this amount or not. So what is this amount? This amount is 100 only, right? So this is the case we are checking for. Okay, now let's save it. We can make another test case, and then we will test our test cases, and that test case will be should not reimburse, if not borrower. Okay, so borrower can only call this reimburse function, right? So we will check that. Now in this we will have again our expect revert, and we are going to call this loan dot reimburse from, let's say this function was called by the accounts 3. Okay, so we are not checking, like borrower address is accounts 2, right? Not borrower address is accounts 1, and we are calling it from accounts 2. Okay, so this is what we are actually checking for, which means we are actually calling it from a wrong account address. Let's say we are transferring the amount plus the interest. Okay, so this is the value of our, like this is the value that we are actually transferring back to the lender. But if this is not true, in that case what we are going to print, in that case we are going to check it against this statement, right? Only borrower can reimburse. So let us paste this here and let us save this. So now let us test these test cases whether they are working right or not. Wonderful. So here you can see that all the test cases are passing. Okay, so this is working absolutely correct, but the work is still not done. We have to make some more test cases. So now we will make another test case to check the amount. So it will be, it should not reimburse if not exact amount. And now we will check for await, expect, revert, and in this we will have our loan dot reimburse function, and we are going to call it from borrower address, and let's say we are only passing value as 50, but the amount that borrower should pass should be 1000 plus interest, right? This is how much the borrower should return back to the borrower, like to the lender. We are actually deliberately putting 50 here so that we can have our test case. So now if this amount is not right, in that case what we are going to print, then we are going to have this statement. Copy this down, let me paste it. Okay, not here actually, let me paste it here, and now let us save this. So now the test case that we are going to see is a little bit tricky. So just be alert for this test case because it will be a little bit tricky to understand at first. So I will say that just be a little bit more aware for this test case. So what we are going to check is should not reimburse if loan amount or loan actually has not matured. Okay, so now we are going to check for the time, and now we will have our await, expect, revert, and in this we will call our reimburse function. And who can call this function? This function can only be called by the borrower, right? Borrower. And what will be the value? The value will be amount plus interest, right? Now what we are checking for is whether the time, like let me show you this loan.sol. In this we are actually checking for that require block.timestamp should be greater than equal to end and loan has not matured yet, right? Let me show you here. In this, if you will see, we are checking whether block.timestamp is greater than equal to end or not. And if it is not the case, then we are going to print this statement. Then we are going to have this statement that loan has not matured yet, right? And then we are going to have this state equal to state.close. So this is what we are checking for. So now let me copy this down and you will understand what I'm trying to do. Once let me do this. Okay, now let us save this. And now let us test this. Now before testing this, let me do one thing. Just click on this switch button and then again do this quick start, because we are going to learn a concept related to this transaction and blocks. So now if you will go to this block section, you will find that you have only one block, that is block 0, and this is provided by Ganesh. Okay, and now what we are going to do is, now we are going to truffle test our case, and now we are going to test our file. So now let's test our file, and you will see one important observation here. Let me again come to Ganesh, and here you will see that As soon as the truffle test will start, you will see that block mining will start here. So you will see block 1, block 2, block 3, and so on. Let me again go to this. Okay, it is under compilation. Now let's see here. So now you can see that we have this block number 1, block number 2, 3, 4, 5, 6, and then 7. So how these blocks are actually getting created in Ganache? So when we talk about Ganache, right, for each and every transaction, a block is created. So let me show you what I'm trying to say. Now at this point of time, if we start from the start, here you will see that we have this first transaction where we are actually deploying our smart contract. So this is our first transaction, right? Now this is our second transaction because we are calling this lend function and we are passing some value to it. This is our third transaction, and if we will come here, you will see that this one is our fourth transaction. This one is our fourth transaction, and we will not count this as transaction. Why? Because in this we are just getting the value of our borrower, right? So we are reading the smart contract and we are not actually making some changes to the smart contract. And this is the basic rule of Solidity. I hope you know this, that whenever you are making some changes to your smart contract, then only it will be counted as a transaction. Otherwise, if you are just seeing that transaction, means if you are seeing something from your smart contract, in that case that will not be counted as a transaction. Okay, so no gas will be detected from your account or nothing will be happening if you are just seeing a value. But if you are actually making some changes to your smart contract, in that case there will be a gas deduction from your wallet. So this is our fourth transaction, and then this is our fifth transaction, right? Because we are again passing some value to it by amount plus interest, right? And then we have this sixth transaction, and then we have this seventh transaction, right? And for each and every transaction, if you will see, we have a block. This is for first transaction, for second transaction, for third transaction, fourth transaction, fifth transaction, and seventh transaction. Now why I'm telling you all this? If you will see this test case, now you must be thinking we are checking for that loan dot reimburse, and then we are passing the borrower value, means borrower address, which is absolutely correct. Then we have this value which is also absolutely correct, but still it is passing, right? It is still passing, means still we are having a passed test case. If you will see this, you will see that we have this should not reimburse of loan has not. Okay, I have made some mistake here in the spelling mistake, but that's not matter. But the important point here is to note that we have a transaction, we have this require statement which is actually printing this value. We are actually checking for this require statement, right? We are expecting that this require statement will throw us an error that will be loan has not matured yet, and that's the true case also, right? That's why we were expecting a reward for this transaction, and that's what actually happened, right? That's why we have this loan has not matured yet, and that's why we have this statement, means this test case, as passing test case. That's why it is a green tick, not a red tick. So now let us understand why we have this test case as a passing test case and not as a failed test case. Okay, now let me start from the start. Okay, so this was our first transaction, this was our failed transaction, right? That's why, because lender is not able to call this lend function because the amount, not because the sender address was wrong, right? Because the person who is calling this lend function was not the right person to call this lend function. So this was a failed transaction. This was also a failed transaction. But if you will see this transaction, means this fourth transaction, this transaction is a passing transaction. And for a fourth transaction, we have our fourth block, right? So if you will go to our fourth block, now this is the block that we are talking about. And if you will note the time here, this is 4:49:33, means at 4:49 minutes 33 seconds. Though this block was created when this transaction was actually done, right? When this transaction was actually done. And if you will go to our smart contract, in our smart contract, let me show you our lend function. In our lend function, if you will see, when we will call this lend function, then it will check for this, then it will check for this, and since both of these values are true, then we are going for this change state, and we are actually changing the state.active. Now if we will go to our state.active, you will understand what I'm trying to say here. Now this will be true and this will also be true, you can check this. And when we will come to this 2 equal to state.active, because state is actually active because lender has actually called this lend function. Now in this, what we are going to do is, in this, if you will see, we will pass from this also, then we will have this state is equal to state dot active. In this, if you will see, we have this end block, right? We have this end variable in which we are actually having the block dot timestamp value plus some duration. Now what is this block dot timestamp? Now block dot timestamp is the time at which this block is created, means the transaction for this block is created. Now the time at which this block was created was 16:49 and 33 seconds, right? Now for simplicity, let's assume that it is 33 seconds. So block dot timestamp is 33 seconds. Let's assume for simplicity. Okay. So it is 33 seconds plus some duration. And what is that duration? So this duration, if you will see, this duration is nothing but the value that we are passing from our migrations file, right? Because we are passing some value from a migration file to this constructor, right? So let's go to our migration file, and in the migration file we are passing 100 as the duration, right? So if we will come back, to our loan.sol. So now our end, now this end is actually consisting of 33 plus 100, right? So now our end variable consists of 133 seconds, because when we talk about transactions and whatever things that are going on in our smart contract, we talk about in seconds only. So this is 133 seconds. Okay. Now let's go back to our test file. Now in this test file, if you see, now we have called this function, right? And this function, if you will see, not actually function, this test block. Now this function, this transaction is happening at 7th block, right? And if you will go to our Ganache, so this is our 7th block, and it is actually being created at 16:49:35, means this was created at 16:49:33 seconds. It was at 16:49 and 35 seconds. Okay. So from this, what we can assume is, let's go back to our loan.sol. In this, if you will see, we are actually calling this reimburse function. This is passing, and then we are calling this state.close, and we are going for this state.close, and where we are checking for this is true. This, now let's talk about this statement. Now if you will check for this case, what is the block.timestamp? Block.timestamp for this transaction is nothing but it is 16:49:35. So let's assume for simplicity that it is 35. You can also assume as 16:49 and 35, but that will be a difficult thing to understand what is actually going on. So for simplicity, we are assuming that it is actually created at 35 seconds. So now the question is whether 35 second is greater than end, and end is what? End is 33 seconds, 133 seconds. So definitely 35 is not greater than but less than 133 seconds, right? Because this is what we have in our end variable, and that's why this transaction will fail, and that's why we will have this error that loan has not matured yet. And that's why if you will go to this loan test.js, you will see that we have loan has not matured yet as the error, right? So that's why we have this passing test case. But if we will make some changes, to our duration variable, right, to this duration variable, definitely we can have a wrong test case, and let me show you that also. So for that, what we will do is we will just make some value, that is let's make this duration as loan.js. So for this case, if you will see, for this case, I know it's a little bit tricky, but if you will just have some patience, if you will rewatch this video, you will understand it. So in this case, 100 was the duration, right? So let's make duration something which is actually less than 35, right? Because if duration is less than 35, and that means not 35, means the entire value is less than 35. So in that case, this transaction will, means this required statement will pass, and then we will not have this loan has not matured yet error. So let's make our transaction or duration, sorry, not transaction, as second. So now what we are trying to do here, just listen to it very carefully. Now the duration is 2, right? So for our case, for this test case, now, okay, sorry. So for our test case, now what we will have 33 plus 2 as the duration. So now the value will be 35. When we will again test our file, you will see that. So for now, you will see that we have 33 plus 32, because the duration in this case is is 2, right? So duration is in this case is 2. So that's why it will be 33 plus 2, 35, and 35, if you will see, is greater than or equal to 35, right? Because end now consists of 35 and block.timestamp was created as 35. So what we will have here is 35 equal to 35. Let me now show you this. So what I am trying to say, you will understand it in just a second. Okay, now let me again truffle test this, and you will see that this transaction, not this transaction actually, but this test case will now fail. So here you can see that we have this failed transaction. So I hope you understand why we have this failed transaction. So if we will have the duration anything less than 2, any duration which is less than 2 will always have a failed test case for this test block. You can check that also. Let me have one here. Let me have one here. And let me again test it. Again, you can see that we have a failed test case. But anything greater than 2, will have a pass test case. And why? Because anything greater than 2 will give 33 plus 3, 36, right? And 36 is actually not less than but greater than equal to n, right? Because 33 plus 3 will give us 36. So now n will consist of 36. And since n consists of 36, now in this case 35, which is the block dot timestamp, that is 35, will be less than equal to 36 because now n will consist of 36. Let me show you this also. So now you can see that we have this passing test case. I hope you understand why and how we are actually doing this. This is all mathematics. Believe me or not, this is all mathematics that we are using for calculation of time. So do not be confused with 33 or 32 or 35. So what I'm trying to do here is, let me show you a little bit more easy way, or I will say a more like a alternative way to think, like how to think about this problem. So let me switch, and again we will have a quick start so that we can have 0 blocks here. So let me again truffle test it for you so that I can show you one important thing, why I'm having this 35, 33, or still if you have some confusion. Now let me show you one important thing. If you will see that block number 4 is created at 50 seconds, right? 1704 50 seconds. And block number 7 is created as 174 52 seconds. Means the time gap between these two blocks, between 7 and 4, is always 2 seconds, right? Is always and always 2 seconds. So that's why in that case, like in this case, I have used 33, 35. But for you, if you want to test it again, you can have this 52 or 52, like 50 and 52 for testing. The thing is, we are actually doing a calculation for 2 seconds. Means for this 2-second gap that we have between these two blocks that are being created. Okay. I know it's a little bit tricky, but believe me, just go through this one. You will understand. Okay. So this is how we are actually testing for this block. Okay, now we will have another test block, but this time it will be a little bit different test block. It will be to reimburse the amount. Till now we haven't reimbursed the amount, right? But this time we are going to reimburse the amount. Reimburse, and then we will have async. And now we are going to use one important function, that is time.increase function, which will actually increase the block.timestamp for this block, for the transaction we are actually calling for, by duration plus 10 seconds. Okay, so let me again make the changes in our migration file. Let me again make it as 100 only, so that will not be an issue. And if it is 3 also, then also it will work. That's not the problem. Okay, you can have 3 also, anything you want, that's your choice. But now what we are doing is, for this transaction we are actually increasing the block.timestamp for this block by duration plus 10. So whatever duration we have, so let's say in this case you can see that we have a duration of 100, right? So now whatever, at which time, like at, let's say this block is created at, for example, 33 seconds. This block is created at 33 seconds. So what we are trying to do is, we are adding 100 plus 10 to this block.timestamp. So now this block is actually created at 143 seconds. So this is what we are trying to do. And we are using this OpenZiplin test helpers library for this, for which I will definitely share you the link. Let me remove this assertion because we do not require this package. And we do not require this also. Now let me save it. Okay. So now we will check for the reimbursement. So first of all, we will have balance before. In this, we will have our web3 dot utils dot to bn await web3 dot eth dot get balance lender. So we are actually getting the balance of our lender, and then we are going to have loan dot reimburse. Now we will call this reimburse function from the borrower's account, and the value will be, since we want a reimburse, right? So we will have the amount as plus interest. And now we will have the balance after of our lender. Okay, this is actually giving us some error. Okay, we should not have these brackets, right? That's why it is giving us an error. Okay, now loan dot reimburse from borrower and the amount, and now we will have the balance after. And let me copy this again so that we can have the after balance of our lender, so that we can check whether the amount has been transferred back to the lender or not by the borrower. And then we will have the state variable. We will check the value of this loan dot state assert state dot to number, and it must be equal to 2, right? Because we are closing the state. If you will go to do loan dot solve, in this we are actually closing the state, and for state dot close 0, this is 0, this is 1, and this is 2, right? So we are checking for that. And now we will have our assert, and in this we will use the balance after dot subtract, and we will subtract it from the balance before, and now we will convert it to a number, and now we will check it against the amount plus interest. I think this is easy, no need to explain this. So now let's try for this test block, and this will take care of the time, right? This will take care of this this require statement. So now the block dot timestamp is already greater than, because we are adding a time of duration plus 10. So this will already be greater than the end time. Whatever end time will be there, it will already be greater than this end time. So now you can see that we have this should reimburse also. If we will remove this, now, this will definitely give us an error, and we can check that also. Let me remove this so that I can show you that. Let me test this. So now again we will have this, like for this test case, like this test case only, we will fail in this, because we are not checking for should not, we are actually checking for should, right? So we are not expecting a revert here. So this will definitely give us a revert, and this test case will fail actually. So here you can see that we have this VM exception while processing transaction, revert loan has not matured yet, and that's why the reason of this. So if you want that your test case pass, just increase the blocked out timestamp by this duration. Okay. And is there any reason why I have this 10? No, there is no reason for this. Definitely you do not want, you can change it. Okay. That's no reason. Just this is I have done randomly. So you can have any amount, like any time here. That's not the case. So I hope you understand how this time of OpenZiplin test helpers actually works, and you find this video helpful. So if you have any doubts, definitely please comment below. But I will suggest you, if you have any doubts related to this test block, I will suggest you just go through this test block like this video once more. You will understand it, because this is all maths that I have done. If you are still confused, then definitely comment it out. I will try to help you. Okay. So meet you soon in the next video. Bye bye. In this video, we are going to discuss about ERC20 token. So let's begin. And before moving further and talking about ERC20 token, let's first understand what is a token. A token is a cryptocurrency that represents an asset or specific use and resides on their blockchain. Now, what does this definition mean? Because I think it is a little bit complicated, right? That tokens are a type of cryptocurrency that represent an asset or specific use and resides on their blockchain. So let us understand this with the help of an example. Let's say you want to buy some cake from this bakery shop. And in order to buy this cake from this bakery shop, definitely you have to pay some money, right? So when you will pay this some money to this bakery shop, then this bakery shop will provide you with cake. But this bakery shop operates in a different manner. Instead of providing you with a cake, what they actually provided you with is some tokens. Now, with the help of these tokens, you can buy anything from their shop. Let's say you paid, let's say $100 to this bakery shop. So what they provided you with, they provided you with these tokens. And they said, okay, if you want to buy anything from our shop, you have to use this token. And now this token can be used to buy this cake. Now, if we go back to our definition of tokens, tokens are a type of cryptocurrency that represent an asset or a specific use. Now, in this case, this token is actually representing an asset, and that asset is this cake, right? So, tokens are a type of cryptocurrency that represent an asset or specific use, and like these token only, our cryptocurrency token also represents some assets and resides on their blockchain, because different blockchain have their own tokens. So definitely every blockchain will have their own token, so that's why they are saying that they resides on their blockchain, not on any other blockchain, but on their blockchain. So this is what tokens are. Tokens are simply cryptocurrency that represent an asset or a specific use, and I think this example is more than enough to understand you how we use token in our cryptocurrency world. And we are also going to talk about tokens in more detail when we are going to talk about our ICO smart contract. Now let's talk about ERC20 token. So what are ERC20 token and what is the full form of ERC? So ERC stands for Ethereum Request for Comments, and ERC is a form of proposal and its purpose is to define standard and practices. So what is ERC? It is just a proposal that is used to define standard and practices. In the same way, ERC20 is a proposal that intends to standardize how a token contract should be defined. Now, what do I mean by that? In simple language, let's say you want to make some decentralized exchange, or let's say you want to make some wallet and you want to use some smart contract. Now, for all these type of applications, you can use ERC20 smart contract because it will provide you a structure, it will provide you a standard how you should have a smart contract inside your wallet or inside your decentralized exchange. And that's why ERC20 token is also used for many financial applications. When you talk about ERC20 interface, it has 6 functions and 2 events. And let's see how ERC20 token works in our Remix ID. So now let us make our ERC20 token by inheriting ERC20 interface. First of all, we will make our contract. Let me name our contract as block is. Now I am actually implementing this interface, ERC20 interface. And now we are going to declare our state variable. First will be name. What will be the name of our token? Let me name it as block. So this is name of our token. Okay. Then string public symbol. What will be the symbol that we are going to give our token? For example, like Bitcoin has BTC, Ether has ETH. So in the same way, let's have BLK for our token. String public decimal. Now this variable tells us up to how much decimal places our token will be divisible. Generally for ERC20 token, it is up to 18 decimal, but for our example, we are going to have 0 in it. Okay, so we are not going to divide our ERC20 token into like a very small ERC20 token, something like that. Then we will have our uint public override. Now why I'm overriding this? I'm overriding this because we are actually implementing our ERC20 interface, right? And this function belongs to our ERC20 interface. That's why I have to override this function. And we have talked all about this in our interface video, right? So let's do this. This will tell us the total supply of ERC token that we are going to have. Then we are going to have another variable that is founder, who is actually the founder of this ERC20 token or this block token. Then we are going to have a mapping. This will be address uint, means the key will be address and the token, or not actually a token, actually the value will be uint. Public balance. Now this will keep the track of the balances belonging to a particular address. Okay. Now let us make a constructor. Now let me initialize it with total supply, and now let us have 10000. Okay, this much token in supply. Then the founder is the person who is actually calling this contract or actually deploying this contract, message.sender. And now the balance is founder. The balance of the founder will be total supply, right? Because initially the founder has actually deployed this contract, and initially we haven't like distributed our ERC20 token to anyone, right? So initially all the total supply of our BLK or block token will be present into our balance of our founder, right? Now we are going to make another function, that is balance of, and with the help of this balance of function we are going to determine the balance of a particular token owner. So this is address token owner, then public view override, because this is also present in our ERC20 token interface, that's why returns the balance will be in uint, so we are going to return this in a balance variable, and return balances, we are going to use our mapping, then token owner. Okay, so with the help of this we are going to determine the balance of a particular token owner, and we are using this mapping for this, right, which is useful in determining the balance of a particular person or a particular token owner. And then we are going to create another function by the name transfer. This is also present in our ERC20 interface. Transfer, with the help of which we can transfer ether to a particular address. We are going to take two arguments in it, to which we want to transfer ether to, not ether actually, token to, and then uint tokens, the number of tokens that you want to transfer to this to account. Public, we are going to make it override, returns, and bool success, it will return success to us. Require balances. First of all, what we are going to do is we are going to check whether the message.sender has enough amount of token in his account, right? Okay, tokens, if it is successful, then balances to, now we are transferring token. For this we are going to do tokens, so this is same as writing balances to equal to balances to plus tokens. Okay, like this. So in this way we are transferring token to this to address, and now we are going to subtract the same amount of tokens from the message.sender account, minus equal to tokens, right? And now we are going to emit our event, our transfer event, which is present in our ERC20 interface. Transfer stake, right? Transfer message.sender means who is the person who is actually sending this token to the address we are sending this token to, and tokens, the number of tokens that are being transferred. And then if this all true, then we are going to return. Okay, now actually I made a mistake, we should write true, right? True. Now we are going to declare one more mapping, that is for the approval process, and I'm going to discuss about this in detail. Just wait for some time. Address, and this will be a nested mapping. Now what is this nested mapping? I'm going to tell you everything about it in detail, so don't worry about it. uint, or not actually uint, actually address, and then uint. Okay, so this is the nested mapping, and I'm going to discuss about this in detail, so don't worry. Allowed. Okay, this is for the approval process which we are going to make. Now we are going to make a function. We are going to make a function prove. approve. And this is also present in our ERC20 interface. If you want to see, you can see that this is also present in our ERC20 interface. And now I'm going to do address, spender, then UINT tokens. Now the address of the spender is the person whom we are actually approving that okay, you are allowed to use my tokens, something like that. It is just like writing a check to a person, like okay, this is a spender and I'm writing a check to him. Okay, now you are allowed to take money from my account. So this is a approval process. So this is just to approve that okay, you are authorized to take money from my account, and in this case the tokens from my account. Public overwrite returns full success, right? Means if this particular function is successful, then we are going to return success, means true actually. Require, first of all we are going to check the balance of the owner, means the message or sender, whether he has enough tokens in his account or not. Then we are going to check the number of tokens that are being transferred, so it must be greater than 0. Then we are going to use our allowed mapping. So I'm going to do allowed, then message.sender, then spender, and then equal to tokens. Now what is this? I'm going to explain you just in some time. Emit, now we are going to emit our approval event with message.sender, the person who is actually approving, the person to whom he is actually approving, and the number of tokens he is actually approving for tokens. And if everything is successful, then return true. Okay. And now let us see what is this nested mapping, how this nested mapping actually works. Now let's talk about the nested mapping that we are using in our smart contract, which looks something like this. Now why it is a nested mapping? This is a nested mapping because we are using a mapping inside a mapping. That's why it is a nested mapping. Now how we can use this nested mapping? Now to use this nested mapping, what I will suggest you to imagine this nested mapping like an array, like a 2D array, which looks something like this, where the key of this mapping are address 1, address 2, and address 3, and the key for this mapping is address A, address B, address C, and this UINT is the block. So when I'm doing something like this, so what I'm doing is I'm saying address 1 has allowed address B of 100 tokens, which looks something like this in our 2D array. But definitely it is not a 2D array. Remember this is not a 2D array, but you can imagine it like a 2D array for making your work much simpler. And let's say if I am doing something like allowed address to address C, so it is something like address 2 has allowed address 3 of 200 token. And what are these address 1, address 2, and address 3? These are just the addresses that are present in our remix ID, which we can see here also, right? These are the addresses that we are talking about, this address 1, address 2, address 3, address A, address B, address C. And if we will go back to our approve function, so in this allowed message.sender spender equal to tokens means message.sender is actually allowing this spender of these number of tokens. Okay, so this is how we use this nested mapping data structure. And now we are going to make our allowance function. Allowance. In this we are going to have two arguments, address, token owner, and all these things are actually present in our interface. Okay, what I'm doing is actually present in our interface. So I'm just using this only. Token owner, then address spender. Now with the help of this allowance function, what we are going to return is the number of token the token owner has actually approved the spender for. Okay, so public override, because we are using it from the interface, returns UINT remaining, or actually we can write it as let's say number of tokens, and then we are going to have return allowed. In this we are going to have our message dot, not actually message dot sender, but the token owner, and then spender. Okay, So this is the mapping that we have used in our approve function, right? So we are just returning the number of tokens from it, okay? And we have seen this, how this mapping works with the help of our presentation. Okay, there is some issue in it. Let's see what is the issue. Function address view to be non. Okay, I haven't mentioned view here, right? Okay, and now we will make our last function, that is function transfer from. So with the help of this transfer from function, we can transfer ether from one address to another address. Address to, then uint tokens, public, override, returns, full success. This function is successful, then we will return true. Require allowed. So in this case, we are going to check our allowed mapping, whether the approval has been given for the token or not. It should be greater than equal to the tokens. Then require balance. Then we are checking the person who is actually transferring tokens, his balance should be greater than equal to the number of tokens that he is actually transferring for, right, in the argument. Now we are going to have balances from, now we are decreasing the number of tokens, yes, equal to tokens. Then we are increasing the same number of tokens, the person to whom the tokens has been transferred to. So, tokens. Then if everything is successful, then return true. Now we have successfully implemented our ERC20 interface. Now let's check our ERC.solve smart contract. Now let us test our smart contract. So let me compile it, deploy it. Okay, so now we have all our functions and variables. Let us check the total supply. Okay, it is 1 lakh. Symbol, BLK, name, block, founder, 0 into 5B3, because this is the address who has actually deployed this smart contract, right? That's why founder is 0 into 5B3. This is what we have mentioned in our constructor also, right? Now let us check decimal, it is 0. Okay, now let us check the balances. So balances is a mapping, right? Where it balances, okay, here it is. Now let us check the balance of our founder. So let me copy this from here. Now let me paste it here. Okay, 1 lakh. Now let me check this also. Balance of, it is 1 lakh, right? So balance of is a function, right? Balance of is a function, and balances is a public mapping. Okay, now let us check the transfer function. So let me transfer some tokens to some other address. So let me copy this, because we are using transfer function, right? Address to the address to which we want to transfer and the number of tokens. So let me paste it here. Let me check the address whether it is correct or not. Yeah, it is correct. Now let me transfer, let's say 1000 tokens to this address, and this transfer will take place from founder address, right? So let me again click on this. Why founder address? Because we have checked a condition here that balances of message or sender should be greater than equal to tokens, and for now only founder has the total supply, so he will be the one who will be transferring some tokens to this address. Okay, so now let me click on transfer, and our transaction is successful. Now let us check the balance of this account. We copy it from here. Now let us check the balance of it. Paste, and he has 1000 tokens in his account. Now let us check our allowance and approve function. Now before going for allowance, we have to go for approve, because first of all we have to write a check, right? Because approve function is like just like writing a check. So before first of all we have to give an approval, then we will check the allowance, and then we are going for transfer from. So let us go for approve, and in this we have to mention two things: the spender and the tokens. So let me take this address. Now this address will call this approve function, and let me make 0CA3 will be the standard for this test purposes. For testing purposes, I am taking this address. I am copying this. I am actually clicking on right? So approve. Now let's say I want to transfer 100 tokens to this address, okay? And this token will be transferred from 0AB8, which already has 1000 token in his account. Now let me click on approve. So our transaction is successful. Now let us check the value of our allowed mapping, right? Because this is what actually is there in our allowed mapping, right? Message.sender was this address 0 into AB8 because he was the one who called this approve function, and spender was this address, right? Now let us check the value of our allowed mapping. So allowed mapping will this we have to use this allowance function, and this allowance function take two arguments, token owner and the spender. So token owner was this address 0 into AB8. Let me paste it here. And the spender was this address, right? So let me paste it here. Okay. Okay, let me check the address because I think I haven't copied the address properly. Yeah, I haven't copied it properly. Let me remove this. So let me copy this. This is the spender address. Now let me copy it again. Okay, now it is copied. Let me go for allowance and let us check whether 1000 is actually being displayed or returned from this allowed mapping or not. We click on allowance. Okay, now we have 100 tokens from our allowed mapping. Reason being because we have approved for 100 tokens, right? We have approved for 100 token to this address. That's why, and we can check this also. We have approved for 100 tokens, so that's why it is showing 100 tokens. Now let us go for this transfer from function. And in transfer from function, it will take three arguments, that is a from, address to, and tokens. So this will be the address who will be transferring some tokens to this address, and this will be the number of tokens. And before that, it will check the allowed mapping, right? So we have taken two addresses. So let me take this address again. Let me copy it. Now let me paste it here, comma. Then this address, because we have approved for these two addresses only, right? Transfer from. So now let me paste it here. Again, I made a mistake on copying the address. Let me again copy it. Now the address has been copied. Now let me paste it here. Okay, and let's say I want to transfer 90 tokens. Means if you will see this allowance mapping, we have approved for 100 tokens, but I only want to transfer, or the spender only wants to take only 90 tokens. So we can do that. So let me click on this transfer from, and let me click on this transfer from. Okay, the transaction is successful. Now let us check the value of this 0CA3 account. Now let me click on balance of, and here we can see 90 tokens are there in 0CA3 account. And if we will check the balance of 0AB8, we will see balance of 910 ether. Earlier it was 1000 tokens, now it has 910 tokens. Reason being 90 tokens has been transferred to this 0CA3 address. Hi. So now in this video, we are going to start with ERC20 token.sol smart contract testing, and it will be an exciting video because in this video, we are going to learn about various new concepts related to smart contract testing. So let's start. So this is our ERC20 smart contract token. Okay. So for testing of our ERC20 token.sol smart contract, we need some packages. So first of all, let me import those packages, revert, and then we will have expect event, and then we will have our require, and in this we are going to need a package called open ziplin test helpers. So you need to install this open ziplin test helper package to have this expert revert and expect event, and you will understand it like what is the use of this. First of all, let us install this. To install this, simply just go to your terminal and type npmi and then just this package. But I already have this package, so I do not need to install it, but for you, just install it. And while installing, if you find some issues, just go to your command prompt and run this command prompt as an administrator. Now how to run this? Just go to command prompt run as administrator. So this will run your command prompt as an administrator, and then install this open zipline test helpers inside your package, like not to your package, actually to your folder. Like I'm using ERC20 folder, so whatever folder you are using, just use that folder. Like just go to that folder and then install this package. Okay, and for Linux users, simply type sudo and then write the command. Okay, because this sometimes requires an administrator access, so that's the problem. Now let us go back and then const token and artifacts dot require, and in this case we are going to have ERC20 token dot sol. Now if you will see, this is something different. Like till now we haven't used this dot sol, right? But if you will go to this ERC20 token dot sol, you will see that we have two contracts here. Actually not two contracts, but one interface, and then we have this contract which is actually inheriting from this interface, right? So we need this entire smart contract, this ERC20 token dot sol, this entire smart contract artifact, not just this ERC20 token, means this contract. So we do not require just the artifact of this contract ERC20 token, but this entire file artifact. So that's why we are actually importing this entire file. And now we are going to have our contract ERC20 token, then accounts, let token. So then we will have our initial balance, the balance that we are going to put in inside our ERC20 token, is the initial amount of token that we are going to apply to our ERC20 token dot sol smart contract. So we will have web3 dot utils dot two-way. So we are going to transfer as an initial balance 1 ether, and since all the transactions we do is in terms of way, right? So I'm converting this 1 ether to way, and now we will convert this way to this 1 ether way. Means 1 ether way means this 1 ether, actually I can say that this is 1 ether, and now we will convert this 1 ether to an object. Now to convert it to an object, we are going to again use web3 dot utils dot to bn. So we are converting it to a big number object. So remember this one is actually ether, and we are converting this 1 ether to way. Okay, now we will have our before each, and in this we will have our async. And now what we are going to do is we are going to have an instance of our smart contract, and to create an instance of our smart contract, now we are going to use some different kind of syntax. So we will use await token dot new. So this is a different syntax, right? And then we are going to pass arguments to our constructor. So the first argument that you will see inside our constructor is name, then we have symbol, then we have decimals, and then we have initial supply, right? So for the name we will have our my block. Definitely you can have any name you want. Then for the symbol we can have blk, and for decimals we can have 18, and then for balance we will have our initial balance, this initial balance variable, right? Means 1 ether as a balance, not actually 1 ether. When I'm saying 1 ether, do not be confused like 1 ether. What we are actually trying to do is we are converting this 1 ether into a big number. Means, so what we are trying to do in our smart contract is we are actually taking this as the total supply of tokens in our smart contract. Like means this is the total supply of our ERC20 token. So this is what we are actually doing in this. Okay, and you can print this also if you want to. Let me print it for you so that you can see that. But now it is a big number object, right? So let us do one thing. Now just for the sake of simplicity, let us console.log this amount, so that you can see that also and you are not confused about it. And this will be actually a big number, so we have to convert this number to a string. Okay, otherwise it will give you an error. Let me show you that. So when we are going to have truffle, then we are going to have test. Let's see. Okay, we do have some error. What is the artifacts is not defined? Okay, I made a mistake in the spelling, right? Should be artifacts, not artifacts. That was the mistake from my side. Sorry for that. Let us save this. and now let it true. Test this again. Okay, again we have some error. Now what is the error? Okay, again, oh so sorry guys, again I have made a mistake. I have written wrong spelling of utils. So sorry for this also. Utils, you must be thinking like I'm a very bad typer. Wonderful. So now here you can see that this is the thing what I was trying to explain you. So this amount is actually way. Okay, not actually way. This is a string at this point of time because we have converted to a string. So this is the total supply of our ERC20 token. So this just keep in mind. I will just comment it out so that you can see that in future also for reference. So you can check your total supply of token by doing this type of stuff. So now let's start with our test case. The first test case will be should return the total supply. So we are checking for the total supply of the tokens. So first of all, we will have a variable called supply. In this, we will have our await. Since token now consists of the instance of our smart contract, right? So we can use it and we can call the total supply, and then we will assert supply dot equal to initial balance. Now let me tell you why we are using this type of syntax, because supply, this will actually return us with an object. So now to compare two objects, because initial balance is also an object, right? In this case, if you will see, that's why we have converted to an object, so that we can means we can actually compare these two objects. So we are comparing this supply object with this initial balance object, and that's why we are using this method dot equal. So this is dot eq, means we are actually checking for supply, whether supply is equal to the initial balance or not. So if it is equal, then definitely we will have a pass test case. And let me show you that also for your better understanding. Let me show you supply, because initial balance we have converted to a big number object, but let me show you supply. I'm doing this like these are small things, but I'm trying to make you explain these small things because I believe this is very necessary to understand, like how this whole concept is actually working, so that you can test any smart contract by yourself. So that's why I'm doing all these things. So you can see that we have a big number object, right? So supply is a big number objects. That's why we have actually checked it for. Now we will test, and this is our past test case also, means the total supply as well as the initial balance are the same, and which should happen, because if you will go to your smart contract, so in this we have a total supply, right? This is our initial supply. Let me, and here you can see that we have this total supply, and this is a public variable, and since it is a public variable, so our total supply function is already been created by Solidity for us, right? And that's what we are actually checking for. And in this total supply we have actually inserted this initial supply also, right? So these two things must be equal, right? This initial supply was the amount that we have transferred as an initial balance here, and this initial balance was transferred to this total supply, and we are checking with this, like we are checking this total supply with this initial balance only by calling this total supply function. Now we will test another thing, and that is should return the correct balance. So now we will check the balance of our tokens. So for that, let us create a new variable balance await token dot balance of. So we are using balance of function of token contract, and we are checking the accounts zero balance. So account zero is the one who is actually calling this smart contract, right? By default. So assert, now we will check the balance dot equal, because balance is also an object. So we are now checking it against initial balance, which is also an object. Okay. And now we will check for another test case, that is should transfer token, right? That the token of the token transfer is actually taking place or not. So token, then we will have our async. So first of all, we will have our value. In this value, let us transfer some balance. Let's say web3 dot utils to va. So we are transferring this 100 as a balance to this value. Okay, we are converting this 100 as a object, just like this. In this case, what we did, so this value was giving us this huge number, this 1000 number, and we have converted that huge number to this binary means to this object, right? To this bn, like by converted it to a big number object. In the same way, we have converted this 100 to a big number object so that we can compare it. Now we will have our receipt. Now you will understand why I'm using receipt in some time, because now we are going to use our expect event method. So await token dot transfer. Now we are calling this transfer function accounts one. Let's say we are transferring to accounts one a value 100, means we are transferring 100 tokens to this accounts one. Now we will check the balance. Await token dot transfer accounts 0. So now we are checking for the balance of account 0, and then we will have a initial balance, and this will be web3.utils.bn web3.utils way. So this was the initial balance, right? So we are declaring this inside our test case also. Should be balance. So now we will check assert whether the transfer has been taking place or not. So balance one dot equal should be equal to, actually must be equal to, initial balance dot sub, means subtracting this value. Now let me tell you what we are trying to. So if you will see, we are checking whether this balance one is actually equal to this number minus this number. Means if you will see the balance of our account 0. So after transfer, like since you can see that account 0 has transferred some value, means 100 tokens to this accounts 1. So now our account 0 consists of what? It consists of this 100,000 big number minus 100, right? So this is the balance of our account 0. This must be because 100 tokens has been transferred from account 0 to accounts 1 by this, right? And now what we are doing is we are actually again calculating the initial balance, means this big number 000 dot dot dot. And now in this, what we are checking for, whether this balance one, means this number, this remaining number is, let me copy this for you. So we are checking whether this number is equal to this initial balance. Initial balance means this, again this big number, whether this is equal to this big number minus this 100, right? Because the value consists of 100 only, right? 200. So this must be a case, right? This should be equal, because you can clearly see here that we have these two numbers subtracting each other against these two numbers subtracting each other. So these two numbers must be equal, right? So this is what we are actually checking for. And I hope you understood it. It is a very simple mathematics, nothing more. So just simple transfer of simple transfer of tokens from one account to another, and then we are checking it for against the initial balance. Simple as that. And now we are going to check our expect event. So in this expect event, first of all, we will tell the event that we are expecting. So this is the event we were expecting, right? This was the event. So we will have this receipt, because this test case was all about should transfer tokens. So this was the receipt that we were actually checking for. Then the event name, let me name the event as transfer. And then we will have from which account this transfer was done and to which account this transfer was done, accounts 1, and then how much tokens, like what amount of token was actually transferred. So we are actually telling all these things. Now why we are doing this, let me show you this transfer function. So this is our transfer function, right? This is our transfer function, and inside this transfer function you will see that we have an emit. We are actually emitting an event with this message.sender, means the person who has actually called this transfer function to whom we are actually transferred the tokens, and the value, the amount of value we have actually transferred to that person, to this to address. So this is what we have done here also, from to and the number of tokens. This is the event name, and then you have this receipt means which event you are actually checking for. And we were checking for this transfer function only, right? Because we were actually checking this transfer function. So that's why I've written it as a receipt. And you can see this in the documentation of OpenZeppelin test helper, which I will definitely share you with you. So there you can see this syntax structure also. And don't worry if you haven't understood it just at this point of time, because we are going to use it again. At that time, you will understand it fully. Believe me. Now let us save this. Now let us test this also. Well, and test. Okay, we do have some issue accounts. Okay, I have made some mistake in the accounts variable. Okay, it should be accounts, right? Now let me test it again. Okay, we do have again some error. Let's see. Let's see what is the error all about. Invalid number of parameters for transfer. Okay, I think transfer account 0 value. Okay, so sorry for that. We should not have transfer here, but we should have balance of, right? Because we are actually checking for the balance for the account 0. Let me now test it again. Okay, again, I have made a lot of mistake this time, right? Actually, to type fast, I believe I have made a lot of mistake, which I should avoid. Let's see again. I hope this works this time. Wonderful. So now we have our this test case also passed. Should transfer token. So this is working fine. Means our smart contract is working perfectly fine. And now we will have our another test case, and this test case will be should not transfer token if balance is too low. So at this point of time, we are going to use another of our method, that is expect revert, because we are going to deliberately put some wrong value so that we have a revert. So token dot transfer, we are calling this transfer function, and then we will have our accounts 1 2 but 1. Then we will have our value. Let's say I'm trying to transfer utils dot to be 10 ethers. Now we will have let me go to this transfer function, and here you can see that we have this statement, right? Just copy this exact statement from here and just paste it here. Okay, now let us save this. So now you will see that what we are trying to do is we are trying to transfer from account 0 to accounts 1. 10 means this 10 ether. We are converting this 10 ether to way, so up this big value. But the if you will see, initially the balance of our tokens, the balance of our account 0 was actually only 1, right? When I'm saying 1, so you can understand it as 1 ether only for now, but definitely it is not 1 ether, it is number of tokens. So we are transferring this amount of tokens to our contract, to our ERC20 token.sol, and this amount of token was transferred to our owner of our smart contract, right? So owner of our smart contract consists of only 1 ether, but what we are doing is we are actually transferring 10 ether to this accounts 1. So this cannot happen, right? Because account 0 does not have enough balance to transfer accounts 1 10 ether, because he does not have that amount of balance. So this will definitely throw us an error, or and that error will be not sufficient balance. So what we are doing is we are actually catching this by using this expert revert. So remember that this statement must be same as this statement, otherwise this will throw you an error. Okay, so now let us save this. We can check this also if you want, but let us check this afterwards, or let's check this right now. Wonderful. So here you can see that should not transfer token if balance is too low. If you will make some mistake here, then definitely it will throw you an error, and you can test this by yourself. Okay. Okay, so now we will test for another test case, and that is should transfer token when approved. Okay, now we are going to check this approved and allowance function. So first of all, let us create one variable by the name allowance, then the receipt, because we are going to use it for our event, and then we are having our value in which we will transfer, let's say, web3.utils to big number object, and then 100. Oh, 900, right? So first of all, we are going to call our allowance function from our smart contract. So await token dot allowance So this is our allowance function, which will allow for account 0 and accounts 1. It should be a wait, right? Oh, wait. So let's go to our allowance function first of all. Let's see it. So what is this allowance function is actually doing? It is actually returning us with a allowed value, like how much amount the owner has allowed for spender to spend. And we can check that also, like from our, so where it is. So this is our allowed mapping. Okay, so this is what we are trying to return. Okay, so now we will assert allowance dot should be equal to, or not actually should be equal to, it should be at initially it should be 0, right? Because no transfer or no approval has been done from account 0 to accounts 1. We are just returning the initial value of account 0 and accounts 1, means the owner and the spender. So initially it should be 0, right? And then we are going to have our receipt function, not receipt variable actually, await token dot approve. Now we will approve accounts 1 for, let's say, that value, means this value, this 100 tokens we are approving it for. Okay, now let's go to our approve function. So this is our approve function, right? So now what we are trying to do is, in our allowed mapping, we are trying to message.sender means the person who has actually called this function, that is account 0, spender is accounts 1, right? Spender is accounts 1, and the value that we are trying to transfer, that is 100. So in this case, in allowed mapping we will have 100, right? So now if we will check for our allowance function again, await token dot allowance accounts 0. Now with accounts 1, at this point of time, assert will be of allowance is allowance equal to what? Allowance equal to the value, right? I hope you understood like what we are trying to do. Initially we have directly called this allowance function. Initially it was 0 because we do not have any value for the owner to spender to spend. Then we call this approve function, means this message.sender is approving this spender. Okay, this 100 tokens you can spend for, and that's why we have this value inside our allowed mapping. And this is why, that is why actually we have this allowance dot equal to value, because now after this approve function, the allowance mapping consists of this value. Now we are going to use our expect event, and at this point the receipt was this one, right? This approve function. So we will have this as a receipt, and what we were actually checking for, we were checking for the approval. So that's why we have called this approval function or approve function, right? And now again from, or we can simply say token owner, that was account 0, and then we will have our spender, and that will be accounts 1. So we are allowing this accounts 1 to spend how much tokens? We are allowing him actually 100 tokens. That's why value. Okay, so this is what, this was another test block or it block, but in this we will have some more values. So let me continue further, and this time we are going for receipt, and at this point of time we are going to have token dot transfer from function. Now we are checking for transfer from function of our ERC20 token. So again, account 0, let's say this time we have accounts 2, and then we have our value, and this time let us call this transfer from function from this accounts 1. Okay, so we are calling this transfer from function, where it is. So this is our transfer from function, right? So from to and the value, and who is calling this transfer from function? This transfer from function is being called by this accounts 1. So now we will have our first balance 1. Now we are checking for the transfer from function, right? So balance 1, that will be of our account token dot balance of and accounts 0. So we are checking the balance of our account 0, and then balance of our account 2 await token, because the transfer has been from account 0 to accounts 2, right? Accounts, when I'm saying accounts 2, it is index 2, right? Just to get confused. So accounts 2. So if you will see, this transfer from function has actually transferred from account 0 to accounts 2, and this value, this 100 value, which we have actually initialized here, right? And we can see that. So this is our transfer from function, and here you can see that first of all we are checking whether this allowed means from message.sender, from means the account 0, and message.sender. Message.sender is the person who has actually called this function, and who has actually called this function, accounts 1 has called this function. And if you remember in our previous step only, where it is, we have actually allowed, right? We have actually in our allowed, we have actually checked for our allowed, where it is, this is. So in our previous step only, account 0 has approved for accounts 1 for this value of tokens, right? And first of all, this transfer from function, this is what this transfer from this function is actually checking for, whether the from allowed means allowed mapping for from and message.sender is greater than equal to value or not. And this is the case for us. Then what we are doing first, then we are checking for whether the balance of from means the person, that is account 0, who is actually transferring this tokens, his value is greater than equal to value or not. So we are checking for that. And then we are, if this is the case, means if this is true, and if means if this is true, and if this is true, in that case what we are trying to do is, in that case we are transferring from account 1 means from account, from this account to this account. This is simple mathematical calculation, and I have talked about this in our ERC20 token smart contract. I hope you have watched that video. So we are just transferring from a from account to this to account. Okay, so this is the simple step that we are following here. So now we will have our assert. On this assert will be first of all checking the balance will be equal to the initial balance dot subtract value, right? So the balance, that this initial balance must be equal to the value, means initial balance minus this value, that is initial balance was 1 ether, right? And we have subtracted this 100, actually this where it is, this 100 value. So we are subtracting in this case 1000000, this big value, and from this value we are subtracting this 100. So it is saying that this should be equal to this balance one, and this must be the case, because if you will see in the previous step only, we have transferred from account 0 to accounts 2 this 100 tokens, right? This value, this 100 value. So we have transferred from account 0 to accounts 2 this value only. So the initial balance or the balance one of our account 0 must be equal to this amount, right? And then we are going to assert for our balance 2 equal value. Now what we are checking for, we are checking whether accounts 2 has received this 100 tokens or not. Simple as that. So we are checking for that now. And another interesting thing here to notice about this transfer from function is we are also decreasing the value of our allowed mapping. So from consists of account 0 and message.sender consists of accounts 1, right? So in our allowed mapping, we are decreasing this value. So if we will go back to our test, like this test block, in this test block, if you will see, like we have actually, we have in this allowance mapping, or in this this, when I'm saying allowance, I am talking about this mapping, this allowed mapping actually. So in our allowance variable, at this point of time, if you will see, we have 100 tokens, right? Why? Because clearly we have approved accounts 1 means account 0. In this case, it is a little bit confusing, I can understand, but if you will rewatch this video, you will understand it. So at this point, account 0 has actually approved, accounts 1 for 100 tokens, right? He had approved accounts 1 for 100 tokens. Okay, so that's why allowance at this point is equal to 100, right? And that's what we are checking for, whether allowance is equal to value, means whether allowance is equal to 100 or not. And when we are calling this transfer from function, we are actually decreasing this value. And here we can see that, right? At this point, what we are actually checking for, allowed accounts 0 and accounts 1. So what we are doing is we are actually decreasing it by 100. We are decreasing it by 100. So what we will do, we will create a test case, or we will create this test case also inside our test block. Means we will have our allowance and We will call this token dot allowance accounts 0 counts 1. So now if you will see, this allowance at this point of time will consist of 0. Why? Because of this transfer from function. This is what this line is actually doing. This is decreasing the value by 100. So initially it was 100. Now we are decreasing it by 100. So now it consists of 0. 100 minus 100, that is 0. So we will check for that also. Assert allowance dot is 0 or not. So we are now checking for this. And now what we will do, we will expect an event, and that event receipt will be to call this transfer from function, right? Because we were checking for this transfer from function, and then we will write transfer, and then we will have our from, like from which account the transfer was done. So this is how you can test an event. Okay, so then we will have our two accounts 2, and then we will have the amount of token that we have transferred, that is value, right? That is 100 tokens, and we can save it. Let us first of all check this, because this is a pretty big test case, I understand, and it might be a little bit complicated for you at this point of time, but trust me, just rewatch this video or just go back to these lines once again. Believe me or not, you will understand this, because this is a very simple test case where actually what we are doing is we are simply following this test, means this smart contract. We are simply following this smart contract. We are just adding and then subtracting and making some changes to our mapping. Simple as that. I know you might find it a little bit complicated, but believe me, just have faith and just try to just rewatch this video and try to go for this smart contract and do this test case once again. Just do that. Now we will truffle test it. Let's hope everything, there is no typo at this time. Wonderful. So here you can see that should transfer token when approved is also working absolutely correct. That's a good feeling, right? Now we will have our last test case, and that test case will be it should not transfer token if not approved. Okay, so now we will check for that case. Async await expect reward, because we were actually providing it a wrong value, right? Wrong input. So token dot transfer from accounts 0, and then we have this accounts 1, and then we have this, let's say 10. Okay, and then we will have our allowance is too low. Okay, now let's check this. So what we are trying to do is we are actually trying to transfer from account 0 to accounts 1 and this 10 value of tokens. But in this case, if you will see, let's go to a transfer from. So from is account 0, 2 is accounts 1, and value is 10. But it will be false in this case only. Why? Because from is account 0, message.sender is the person who is actually calling this smart, means this function. So that is also account 0, because we are not actually telling like who will actually call this transfer from function. So by default account 0 is actually calling this function, so definitely it will fail, right? Because means what we are actually doing is we are checking for allowed account 0 should be greater than or equal to value, but that is not the case, right? It is 0, initially it is 0, right? Our mapping consists of 0 in that case. So in that case allowance will be too low. So just copy this same statement, this exact statement, and just paste it here. So this is what we have done also. No, I think I do not have done like that only. So let me paste it here. Okay. So now we can check for this also. Wonderful. So now you can see that all 6 test cases are passing. Our ERC20 smart contract is working perfectly fine. Our test cases are working perfectly fine. That's a big achievement for us, because now we have actually tested the whole Solidity project, that is and that too an important Solidity smart contract, that is ERC20 token smart contract. So this is actually a big achievement. Hooray for you. Hi, so now we are going to see how to test our smart contract using Solidity. Now before starting this video, let me tell you one thing. You will rarely see testing of a smart contract using Solidity. Most of the time you will see testing of your smart contract using JavaScript only. that is through truffle contract library or through Mocha framework. So in this video, we are going to see just an overview of how to test your smart contract using Solidity because it is not much used. So we will just have an overview of how this is actually done. Definitely, I will share a documentation with you. Definitely, if you want to go in depth, you can definitely go for it. But for now, we will just have an overview. Okay. So in order to test your smart contract using Solidity, you have to install a plugin in your Remix ID. And that plugin is Solidity Unit Testing. Search for it, you will see that we have this Solidity Unit Testing. As soon as I will activate it, you will see our double tick here. Okay. Now this double tick, like when I will click on this run button, testing will start. Okay. Like for example, Solidity, like Remix ID has provided us with some contract bellot.sol. Bellot, I believe. Yeah, I do not know the pronunciation if I am wrong, so sorry for that. And then we will go for our run. So when I will click on run, you will see that testing of our this smart contract will start. Okay, it is taking some time. Okay, so here you can see that this is how it looks when you test your smart contract using Remix ID. And let us see the file, bellot test.sol file. This is how it looks, and we are going to see how it is actually being done, so don't worry about it. Okay, so now let us start our own testing of our array.sol file. Now some of you might be thinking like why we are not testing our smart contract using truffle or hard hat. Actually, I am not finding much resources related to truffle or hard hat using smart contract testing via Solidity. So that's why I'm using Remix ID, because Remix ID provides us with resources with the help of which we can test our smart contract using Solidity. So that's why I'm using Remix ID to test our smart contract using Solidity. But don't worry, if something new comes, if some updates come in near future related to truffle or hard hat, with the help of which we can test our smart contract using Solidity, definitely I will update that in our course. Okay, so now let's begin with the testing of our smart contract. So first of all, we will create one full file, that is to test our array.sol, and that file will be, let me this file as array test.sol. Okay, because we are testing via Solidity, so it will be a .sol file. Okay, now let us copy some of these things from here only, because it will be required to test our smart. And we will change this 3.belay.sol because we are not testing this smart contract, right? We are testing our array.sol. We'll have array.sol here. So the concept related to testing will remain the same. Okay. Now, first of all, let me show you this array.sol file because I haven't shown that properly, so that we know how we are going to test. So this is our array contract, and here we can see that we have some functions like store value to push values into this array. We have this get value to get values from this array. We will pass an index to this array, and this will return us with the value at that index. Okay, so this is a get number of values, so this will give us the length of the array. So this is a very simple smart contract, and now we are going to test this smart contract, and the concept related to testing will remain the same. First of all, we are going to have our contract, like in truffle contract library, right? We have like a contract level structure, and in our Mocha framework we have a describe level structure. In the same way, we will have contract here, test array, and inside our test array, first of all, we will create an instance of our smart contract. As I said, the concept will remain the same. Just like in hard hat, we have created an instance of our smart contract. In truffle, we have created an instance of our smart contract. In this also, we are going to create an instance of our smart contract. And to do that, first of all, we will have our array, and we will create our array type variable. Okay, and then we will have our function before each, for each. So this will be called by the remix id, means remix id will make sure that before each function will be called. We do not have to do or worry about it, how who will call it. And then we are going to have the instance of our smart contract array. So that's why we have this array type of this array. Okay, and now we will check the first function whether this store value function is working properly or not. Now in order to do that, we will have a function test store value. Let me make this function public. So what we will do in this store value function, we will pass some value to it, and then we will get the value of that, means whatever value we are passing, and then we will call this get value function so that we can check it against the value that we have passed. Okay, so what we will do is, first of all, let me declare one variable. Let me name this variable as 5, and now we will store the value of this 5 to this store value, like by calling this store value function. Now we will have value here. So what we are doing is we are actually passing value, means this 5, to this store value, means by calling this store value function. So now our array consists of 5 as a value. Okay. Now we will fetch the result, and to fetch the result we are going to use our get value function. Get value function, and we will get the value of index 0. And now we will use the assert. So just like our truffle, we have assert. In the hard hat we have expect. In the same way we have assert dot equal to check whether the result is equal to the value, and then otherwise we are going to have it should store the. Now we will create another function. Now this will to check the number of values in our array. So test number of value. Okay, so to test whether a number of value, means this get number value function, this get number of values function is working properly or not, we will have that. So let me make it public. Now again we are going to store some value to it so that we can get the value and check it against something. So let me have 99 here, and then we will have the new size of our array, and array dot get number of values. So this will return us the length of the array. So this will be the new length. Why? Because we are passing this 99 by calling this store value function. We have this, and now we are going to use assert dot equal new size, and new size should be equal to 1, right? So it will be 1. Otherwise we are going to have it should increase the size. So like this. And we can make one more function to test multiple values of array, whether the multiple values that we're inserting into array are actually being getting inserted into array in the proper way or not. So for that we can have function test multiple value. Okay, and we will have public. So first of all we need an loop, right? Because we are going to check for the multiple values. So we will have a loop. We make this loop as of size 8-bit only, does not take much of our space. Otherwise it won't matter, but just do it in a right way. And in this we will have our value as the array element. So we will have what we are trying to do is we are actually trying to store at ith index the ith value only. Okay, ith index will have ith value, store value again, and we are going to have our value, and then we will have our result. How we have our result? We will have our result by array get value. In this we will have our I, and now we will check again assert equal result value. So inside our loop we are actually having this assert dot equal so that we can check for each and every value, and if it is not right we are going to have it should store the correct value for multiple value, something like this. Do not forget any semicolon because this is not JavaScript. Okay, so now this is our test array, means so not test array, this is our testing of our smart contract. So this will test our array smart contract. So first of all let us deploy compile our smart contract, our array.sol. Okay, now let's go to click arrow. Okay, again we are not seeing this because sometimes actually guys this will cause you some little trouble. Sometimes it will not show you the file value here. Like you will see we do have our test in our test folder, we do have our array test source all right, but still it is not showing. No issue, let me try to rename it as let's say we have 5 underscore. Sometimes changing the name actually works, believe me or not. Remix id sometimes does not work properly. Okay, again we are not having not know why this is 5. So it is showing that we do not have any file even though we have some file. This is one of the issue that I face when using this remix id. Let's try to rename our this also, see whether it will work after renaming. Not. Let us have 4. Let's have 5 only. While in folder. Okay, now it is showing. Now you can see that we have this test 5 array dot. Sometimes again I will say that it will cause you some trouble, but we will not see this like whenever you will create a test file for your smart contract you might not see here. So I will say just try to refresh your browser and try to change the name of your test file and your smart contract, I know it sounds a bit silly, but what we can do, right? So let me uncheck this because we do not want to check this bellot test.sol. Now let us click on this run. Let's see whether our smart contract is being correctly. Okay, we have some issue, I believe. Okay, it is okay. I think it's a mistake. Array.sol. Here it is array.sol. Okay, actually, I have changed the name right. 5 array.sol. Okay, let's try to file it again. Now let's try to run. Wonderful. So now we have our test cases, and all the three test cases that test store value means for this store value is passing, test number of values, this is also passing, and test multiple values, it is also passing. And just see one of the beautiful thing that Remix does for us. We do not have to write like what it did is actually it took this function name and then made a statement out of it. Test store value, test number of value, test multiple value. This is good, right? This is done by Remix ID. Okay, and all the test cases just pass. Let us try to make some error deliberately so that we can check whether it is right or not. So let's try to do one thing. Let's try to have 2 here, right? Let's have 2 here. Now let's try to test. Okay, so now we can see that we have an error. Okay, actually by mistake I have removed this brackets. Let's try to do is test this again. So now we can see that we have one test case false, that is it should increase the size. This test case just false. It means this test case does not pass because we have some error in our test case, right? If you will, I will make this again 1, it will pass, but now you can see that we have an error. So only 2 passed and 1 failed, and this is the one which actually got failed. So expected value should be equal to 2, receive value 1. Is was expecting that value should be 2, that's why it is we have written 2, right? So it was expecting the value should be 2, but actually the value was 1. That's why it is showing the error that it should increase the size. I hope you enjoyed this video. You have understood how we can test our smart contract using Solidity. Definitely I will share one documentation with you where you can search, where we can like deep dive into it, how we do Solidity testing. So meet you soon in the next video. Hi. So in this video, we are going to talk about Hardhat, which is also a tool just like Truffle. With the help of Hardhat, we can compile, test, deploy, and debug our smart contract or decentralized application. So Hardhat is a development environment to compile, deploy, test, and debug your Ethereum software. When I'm saying Ethereum software, it actually means decentralized application or your smart contract. So now the question arises, when we already have Truffle in the first place to compile, deploy, and test our smart contract, why do we need Hardhat? So now let us see what are the differences between Hardhat and Truffle. And one more thing, that Hardhat is also written in JavaScript language just like Truffle. Okay, and now let us see the differences. Hardhat has a faster migration process as compared to Truffle. So let's say you have created a decentralized application on your test network, you have deployed it on your test network, and now you want to migrate it to your mainnet. Okay, you want to deploy it to your mainnet. In that case, Hardhat provides you a faster migration process as compared to Truffle. Second most important difference is that Hardhat has a lower gas consumption when it comes to migration. So whenever you are deploying your smart contract or decentralized application to the mainnet, then in that case, Hardhat will be much cheaper as compared to Truffle because it consumes less gas as compared to Truffle. And the third important difference is that the debugging process in Hardhat is much easy as compared to Truffle. So whenever you are debugging your smart contract in Hardhat, then it is much easier than Truffle because Hardhat provides you an environment where the testing of the smart contract is very easy. And how it is all happens, we are going to see that with the help of an example. So don't worry about it. So this is all about in this video. Meet you soon in the next video. Hi. So in this video, we are going to see how to install Hardhat. And to do that, first of all, we will do npm init so that we have our package.json file. And then just press enter. Okay, and here you can see that we have our package.json file. Now we will write our command to install Hardhat. Npm install dash dash save dash div hardhat. Okay, just press enter. So here our installation process has begun and it will take a while. So meet you after a short break. So here you can see that my Hardhat has installed, and now we will write one more command, and for that let me clear the console. Okay, and now we will write npx Hardhat, and we have to choose from this create a basic sample project. Okay, So we will press enter here, and we will again press enter, enter. Wonderful. So just like Truffle, you can see that all folders are created here. Contracts, which will contain our contracts. Then we have our scripts. So in Truffle, we have our migration.js, right? Migration.js migration folder. In Hard Hat, we have scripts folder in which we will write our migration or deployment script. So here you can see that. This is for the deployment of our Hard Hat smart contract, and which we are going to see in our upcoming videos. So I'm just giving you an overview of this. And then we have our test folder in which we will write our test. And this is hard hat config.json, just like our truffle, which has truffle config.json, right? Not JSON actually, js.js. And then we have our package.json and package log.json. Okay. And now we will install some other dependencies, which you can see here. Just copy all this here, and we are going to see about, and we are going to talk about all of these in our upcoming videos. Just copy it for now and just install them. Okay, a mistake, I believe. We are actually again installing hard hat. First of all, we have to now we will write npm install. Now let's press enter. So yeah, our installation process has begun and it will take a while. So meet you after a short break. So here you can see that my installation has actually failed, and the reason for this is, I think, most probably is because of the lack of permission. So what I will do is I will go to my folder. So this is my folder where I have created my master hard hat. I will open my command prompt, and I will open my command prompt since I'm using Windows. So I will open it as run as administrator. For you guys, if you are using Ubuntu, you have to use sudo command. Okay. So just use sudo and then install all these dependencies. For me, what I'm going to do is I have opened it as an administrator. I have opened our command prompt as an administrator. And what I'm going to do is I'm just going to take this, and from here I will write cd, and then I will paste the path to it. So here you can see that we have our projects here. In this folder, I will cd into our master hard hat. Okay, and now we will install our dependencies again from here. Let's go to our VS Code and let's again copy our dependencies from here, install and all those things. Okay, now let me paste those here. Okay, and now let us install them again. So our installation process has again begun. So let's wait for a while and let's see what will happen. And now you can see that all our dependencies has been installed. I was right, it was due to some permission error. Try to zoom in a little bit. If it okay, it's not happening, not an issue. But I can assure you that here we can see that all our packages has been installed, all our dependencies has been installed, and now we are going to use all these dependencies, in our upcoming videos. So meet you soon in the next video. Hi, in this video we are going to see how we can compile and migrate a contract using Hard Hat. Okay, and we are going to use the same contract that is provided by Hard Hat, that is greeting.sol. So now let us see how this contract is actually working. First of all, we have a greeting variable, right? And then we have a constructor. We can remove this constructor for now because we do not need it for now. Let us remove this. Okay, so that we have a simple contract for compilation and migration. Then we have our greet function, which is actually returning the greeting variable. Okay, and then we have a set greeting function, which is actually setting the greeting variable. And we can move this console.log. What is this? We are going to talk about this in our upcoming videos, like how we use this console.log. For now, let us remove this. Let's have a simple smart contract, okay, which is actually getting and setting the greeting variable. Okay, we can remove this and we can change our pragma solidity to greater than equal to 0.5.0 and less than 0.9.0. Okay, now let us save it. Now let us see how we can compile our smart contract using hard hat. So what we have to do is we have to write npx hard hat and then compile. Now as soon as I will press enter, you will see an artifact folder created here. Okay, So let me press enter here. And here our compilation has finished. It has compiled using 0.8.4 Solidity compiler. This is because of the configuration file, hard hat configuration file that we have. Here we have, see, here we have Solidity 0.8.4, right? That's why it is compiled through 0.8.4. We can change it to 0.8.9. Okay. And here you can see that we have our artifacts folder. In this, we have our build info. Then we have our contracts, the JSON format, greeting.json, which will consist of our ABI as well as our bytecode. Okay, wonderful. So this is how we compile our smart contract using Hardhat. And since we have made changes to our hardhat config.js 0.8.9, let us do this compilation once again so that we can see whether our hardhat configuration is working or not. Wonderful. So here you can see that it compiled to 0.8.9. Now let us see how we can migrate our smart contract using hardhat. So to migrate our smart contract, we have to write npx hardhat and simply migrate. Let us press enter. So this will migrate the file. Okay, we have some error, unrecognized task migrate. Okay, I think I have made some mistake in the command. Actually, the command is hardhat run, then scripts. This is scripts, this folder, scripts folder. Inside the script folder, we have sample-script.js, right? We will write sample-script.js. Let us press enter now. Okay, we do have an error. What is the error? Okay, so here we have an error, and this is because of the constructor, right? This is because of the constructor. If you remember, we have a constructor here, right? And we have removed that constructor. And actually, if we will go to our sample script.js, we are passing this hello hardhat to the constructor. Okay, so we are actually creating the instance of our contract, and then we are passing this to the instance of the contract or to the constructor of our smart contract. So that's why it is giving us an error, because it is expecting that we have a constructor, but we have actually removed that constructor. So what we will do is we are going to remove this, and we are going to talk about this script sample script.js in detail, like in our upcoming videos when we are going to talk about testing of a smart contract. For now, let us remove this. Now let us try to migrate it again. Okay, now let us go back, and now let us try to migrate it again. Let's, okay, again I have, now let us write the migration command. And here we have our contract address. So this migration is successful, and we have our greeter deployed to this contract address, and we are having this because of this sample script.js, because we are actually consoling log this greeter.address. So that's why we have this address of our smart contract. Now the question arises where this deployment is actually taking place. So this deployment is actually taking place to our hardhat network. So hardhat actually provides us with its own network where we can actually deploy our smart contract. So we need not need to have Ganache or some any other thing. We can deploy a smart contract directly to our hardhat network. So in our upcoming videos, we are going to see how we can migrate our smart contract on our live network, means on a test network. And for now, let us wind up this video and meet you soon in the next video. Now in this video, we are going to deploy our smart contract over a test network using Hardhat tool. Previously, we have done this deployment using Truffle, right? But now we are going to use Hardhat as a tool to deploy our smart contract over a test network. Now you have to make some changes to your hardhat config.js in order to deploy your smart contract over a test network. Okay. Now you can see here that I have made those changes, and I will definitely provide you the copy of this file. Okay, so that you can refer it for future references. And here what I have done actually is, like, you might see here alchemy, right? Alchemy API key. So just change it to Infura, because we are going to use Infura API key. Remember Infura that we have used in our truffle section, right? So what I have done is I have taken the Infura API key here and I have pasted it here. Let me show you so that you can have a better understanding. So in our truffle section, we have created a endpoint, right? By using the name as truffle, and inside this we can select any of the networks that are given here, right? So we can select any of the endpoints given from this list. And definitely do not be confused, like, since we are using hardhat, so why we are using something related to truffle. Actually, it is not related to truffle. This is just a name convention. You can name it anything. Okay, you can name it as A, B, C, D, E, F, whatever you want. It doesn't matter. This is just a name that is that we have given to our this like endpoint, the project that we have created in our Infura. Okay, so this is the thing. And just select, since we are going to deploy our smart contract over Robson test network, so select Robson from the list, and then again copy this Robson. Okay, this Robson link, then copy this link, and let me go back to our Visual Studio Code and let me paste the link here so that I can show you what actually I have done. So this is the link, right? So inside our Infura API key, what I have done is I have selected this number, the number or alphanumeric character that is given after this v3 character. Okay, just select this and just copy it down to this Infura API key. Okay, as a string. Remember this, that it should be a string. And then create a Robson private key, just like I have done. And then you have to provide the private key that is actually present in your MetaMask wallet so that we can sign the transaction. Let me show you that also. Just go to MetaMask and let me password here. So we will take the private key from our MetaMask and just remember, never share your private key with anyone. I'm doing this because I am demonstrating you, but you do not have to share your private key with anyone. And remember to select Robson test network only because we are going to deploy a smart contract over Robson test network. To remember this, select account details. Inside account details, click on export private key and then type your MetaMask password. And remember, never share your private key with anyone. Okay, anyone means anyone. I am demonstrating you, that's why I'm showing you. But remember this. So this is our private key. Okay, just select your private key from your MetaMask wallet and then paste it in this Dropchain private key variable. Okay, and I will provide you the file configuration, so don't worry. Okay, so don't worry. And then under this URL section, you can see that I have made some changes. In this dollar sign, I have actually put it this Infura API key. And in this accounts, we have this Robson private key because we are actually going to deploy it to Robson test network, right? So that's why we have to provide some configuration for Robson test network. So this is the URL and this is the account. Okay. So we are actually using this Robson private key, this variable as well as this Infura API key. So both of these variable must be correct. Otherwise, your deployment will not take place over the Robson test network. Okay. Now it's time to deploy. Now let us deploy a smart contract over Robson test network. So let me write the command. So it is npx hard hat run dash dash network, and then we have to type the network name. So it is Robson. If you can see here, right? This is Robson we have selected, and then scripts. Under scripts, you can see that we have this sample script.js, right? You can rename it to deploy if you want to, because most of the time you will see this file name as deploy. You can name it deploy. Okay, just for the sake of convention. Okay, you can also name it as abc.js or anything, just for the sake of convention. Then deploy.js. Okay, yes. Now let's wait for our smart contract to get deployed over Robson test network using hard hat. So it will take a while because we are actually deploying our smart contract over a test network. You have to wait for some time. And here it is. So we can see that we have our contract deployed at this address. Just copy this address because we are going to use it so that we can see on Etherscan. Okay, just copy this. And where does this greeter deployed to comes from? This greeter deployed to comes from this deploy.js file. You will scroll down, you will see that we have this console.log, which is actually providing us the greeter, means this smart contract. This is the smart contract. This is smart contract address is printed because of this line. Okay, so it is not some magic. So because of this line. So now let's copy this and let's go back to, so we are on robson.etherscan.io. Just paste your contract address here and search for it. And here you can see that we have our smart contract deployed to Robson testnet. Doesn't it look amazing, right? And I did it for the first time. I was amazed by this, believe me or not, because you are doing something on the blockchain, right? So it is some pretty thing amazing. I hope you are also finding it. So here we have our parent hash and all the things related to this block, and this is our contract address, who mined this, and this is the block reward given to the miner. I hope you understand how deployment over Robson test network takes place using hard hat. Definitely you can choose any network, means you can go for Ethereum main network, or you can choose Rinkibi network, means you can use any network given at Infura, you can see here, given at Infura, and you can deploy your smart contract over that network. Okay, so this is all in this video. Meet you soon in the next video. Hi, so now we are going to see how to test a smart contract using Hard Hat. And this is a smart contract that we are going to test using Hard Hat. So this contract is a token contract where we are actually producing tokens, but this is not an ERC20 token. This is a simple token that we are just using so that we can see how Hard Hat testing works. Okay, so now here you can see that this is the name of the token. This is the name of the token. This is the symbol of the token, total supply, the owner, and then we have this mapping so that we can have the track of the tokens, the number of the token with the associated address. Okay. And now with the help of this constructor, what we are doing is we are actually taking this total supply that is 1000 and transferring it to the person who is actually deploying this smart contract. And that person would be owner of the smart contract, right? So we are actually transferring 1000 not 10,000 tokens to this messenger dot sender address. Okay, and then we have this transfer function so that we can transfer, and that means this is the address to which we want to transfer, and this is the amount of tokens that you want to transfer. This is the function to check that. I think this is also easy, where we are actually checking whether the amount that is being transferred, like let's say A wants to transfer 5 tokens to B. Okay, assuming so A, who is actually calling this function, must have more than 5 tokens, more than or equal to 5 tokens, right? That's why we are checking it for this require statement, and then we are actually detecting the amount of token that has been transferred from A account to B account, and then we are actually incrementing the token, the balance of the B's account. So this is a very simple, I think, transfer function that is here. And then we have this balance of function to test the balance of an account. So let's say A wants to know how much balance, how much token does he have in his balance. So he can call this balance of function. And now we are going to test this smart contract. Now in order to test this smart contract, we will go to this test folder. And now here you can see this is a sample test.js, but we do not need this because we are going to have our own. So let us remove all this and let me rename it. Let me rename it to token, right? So token test.js. Okay, so this will be the name of our token file. Okay, now the first step will be to transfer aspect from the child library. Now what is this child library? Child library is actually provided by Mocha framework, with the help of which we can easily test our smart contract, and you will see when we will start our smart contract testing. So first of all, we will chai library. Remember, chai is a library and Mocha is a framework. Okay, might be an interview question for you sometimes, so just remember this. Now the first step will be, since we are using Mocha framework, we will use describe. Okay, and I will provide you the documentation of this Mocha framework in the description. You can check that. And now we will write the name of our contract, so that with the help of which we can easily find out which contract we are actually testing for, because you can have many contracts to test for, right? In this case we are using just one, but still you should know like which smart contract we are actually testing for. So you will write the name of your contract and then function, callback function. Now inside this function you will have your test cases, and to declare your test cases you will use it block, and in this we will write what thing we want to actually test for. Like the first thing we want to test for is whether this constructor is actually working properly or not. Okay, whether the transfer of this 10,000 tokens to the owner address is actually properly working or not. So the first thing will be to test it for. So we will check deployment. Definitely you can write anything here because this is your test case, but easy understanding of the test case, because we are going to have many test cases. We should write a proper statement. Supply of tokens the owner. Okay, so we are actually testing for deployment should assign the total supply of tokens to the owner. Okay, and one we will have an async function, because this will involve a lot of promises. That's why we need a async function. Okay, now to start with, we need some address who will actually deploy this smart contract, and for that we are going to use get signer object. Stand once I will write it down, right? Await ethers, so we are going to use ethers.js library. get signers. Okay, remember to remove this because this will not this will actually create a lot of problem for you if you will not remove this. Imported by VS Code. I do not know why. We do not require that package. Okay, so now this is a get signers object. This is a get signers object. You will understand once we will print it out. You will see what is the like what is the use of it, because if I will tell you, you will not still get it. So let us do a practical demonstration of it. Okay, log, and we will print it out. Signers object. Now this signers object in our first line, like this line, at this line, this is actually providing us with the owner. Okay, and this, with the help of this owner, we can find the address of the owner, and you will see that. Okay, owner, and now we will create an instance of our smart contract. So to create an instance of our smart contract, we have const token, then we will have await ethers dot get contract factory. Now this get contract factory is actually responsible to create an instance of your smart contract so that you can then directly deal with the smart contract. Once we will have the instance of our smart contract, we can call the functions as well as the variables, anything that is present inside our smart contract. Okay, so that's why we are using this get contract factory function to get the instance of our smart contract, and inside this we will we pass the name of our smart contract, that is token, right? So the name of our smart contract is token. That's why we have passed token inside it. And now since we have the instance of our smart contract inside our token, so what we can do is we can deploy our smart contract. We can deploy our smart contract. Wait, token dot deploy. So this will help us in deploying our smart contract. Let me write it down. So understanding of smart contract, then we have our deployed smart contract, and now we will have the owner balance. Now why we will have the owner balance? Because with the help of a constructor, what we are actually doing is we are actually transferring 10,000 ethers, not ethers actually, 10,000 tokens to this messenger dot message dot sender, means to the owner's address, right? So what we are doing is we are actually finding the owner's balance. So to do that, we are going to use our deployed address, means deployed smart contract, that is hard hat token. Okay, and then we are going to call the balance of owner. Now you can see that we are using this owner, right? And then we are going to have our dot address, and this balance of function is actually present here. This is the balance of function that we are actually using. Now we have this deployed smart contract, right? So now like with the help of instance of this smart contract, we deployed this smart contract, and now we have the deployed smart contract inside this hard hat token, and now we can call all the functions and variables that are present inside our token dot solve. Okay, now you must be wondering like how this like who is actually deploying this smart contract. Now this is actually done by the hard hat only. Like behind the back, what hard hat is doing is hard hat is taking the default address, by default address, and with that by default address is hard hat is actually deploying this smart contract. Okay, so this is actually done by hard hat only. We are not doing it, but this is actually done by the hard hat only, and you will see that because when I will what I can do is we can also print this owner's address so that we can see that also. Okay, so with the help of this owner's address only, hard hat is actually deploying this smart contract, owner dot address. Okay, and now is the final thing. Okay, here you can see that we have some extra packages. Now what we will do is we are going to have our expect. That's why we actually, okay, I removed the wrong package, I have to remove this. Now that's why we have this expect, right? Because we want to use this here to test whether our contract is working properly or not. Mocha framework also provide us with assert, but since we are using child library, which is actually popular also, so in this case we are using expect. Okay, so for hard hat testing we are going to use expect. Definitely you can use assert also. Okay, but I will say that you should use expect for this because this will give you a better understanding of how other libraries also works. Okay, so we will have await, then hard hat token total supply. Since we have the deployed smart contract, so we can call the total supply function by function. Let me show you. So here we have this total supply, right? And if you will see, this total supply is a public variable. Since it is a public variable, so Solidity has created a public function for it, right? Or not actually a public function, but yeah, we can say that. But a function is created for this total supply because it is a public variable. So I hope you know this. And now we are going to use to dot equal. Now this is a syntax that you have to remember for expect. Okay, you have to remember it. So we are going to use expect await hard hat token supply, means the total supply. That is okay. We have made mistake in the spelling. So this hard hat dot token to supply will actually provide us with this 1000, right? This 10,000 actually. And now we are going to check it against owner balance, which we have actually used here. Okay, now if this is true, means if our constructor is working properly, then definitely it will pass, because if you will see this constructor, 10,000 was the total supply and we are transferring this 10,000 to the owner's address right here at this point. So definitely this should pass, otherwise it will give us an error. Let us save this. Now let us open our terminal, npx hard hat test. Okay, so here we have some error. That's good, because I think errors are good so that we can understand how testing is actually working. But let me show you one important thing. Like, since we have actually printed this console.log, this signers object, right? So this is our signers object. You can see that this is our first of all, this is our token contract. This is our token contract, and then we have this signers object, and this signers object, you can see that we have so many fields, right? And inside this, one of these field is this address, and you will see this same address, you will see here also this. So you can see that this is the same address that is actually being console.log by this line. Okay, so this is what I was saying, like hard hat is actually using this address to deploy this smart contract. Okay, and now let us check what is the issue, why our test is not passing. So we must have made some mistake. Okay, it is saying that hard hat token total supply is not a function. See, okay, we have made mistake in the spelling, right? Should be total supply. Now let us check. I hope everything works fine this time. Wonderful. So now you can see that deployment should assign the total supply of the token to the owner, means this thing, the test block that we are actually working for is actually passing. Okay, and in the upcoming videos what we are going to do is we are going to create more than one test cases so that we can see how this whole, how this whole smart contract should be checked or should be tested. Okay, let me again show you this terminal. This is interesting, right? This is our again signers object, then we have this owner's address, this is the address of the owner, and then we have this passing result. If it was an error, so what was like how this error will look like? So the error will look like this: 0 passing, 1 failing. And what is failing actually? This is what this was actually failing when we have made mistake in our smart contract. And the error was something like this, that type error hard hat token to total supply is not function. So this was a type error, right? That's what the case when we have made a mistake in our test file. And let me do one thing more. Let me make this, instead of since we have hard hat dot token, like hard hat token dot total supply as 10,000, right? Let me check it against 10. Let me check it against 10 whether it is working right or not. Let's see. Let's try to test it again. And here you can see that we have an assertion error. The assertion error is that expected 10,000, because hard hat dot token total supply, this thing is actually 10,000. So it is saying that we are expecting 10,000, but you have used here. That was the error, right? Let me write again so that we can end on a good note. So meet you soon in the next video. Bye bye. Hi. So in the previous video, we have seen how to test our smart contract, right? And in our smart contract token.sol, we have tested this constructor, right? So that we can see whether our constructor is working properly or not. So we have written this test block so that we can test our constructor. And now in this video, we are going to test this transfer function, whether this transfer function is working properly or not. So now let's start and test this transfer function. And since we are testing another function, so we can have a different it block so that we can easily identify which function we are actually checking for. Okay, and you will understand it once I will start doing it. If you are not getting this, just be patient. Okay, so let me remove this console.log, because now we know how this get signers work. And let me remove this also, because now we know how this owner address work, right? Now let us save this so that it is properly aligned. And now let us make another it block. Now what this it block will check for? So this will check for, it should transfer tokens between accounts, and then we will have our async function just like above. And now we are again going to use our get signer function so that we can have accounts, right? But in this case, we will have more than one account. Reason because we have to transfer like tokens from one account to another, right? So for testing purposes, we can have more than one account, and to do that, we have to simply write address to, and here the destructuring will takes place, and get signer will provide us with the different accounts. Okay, ethers, get signers. Now again, we will have the instance of our smart contract. For that, we will have our await ethers dot get contract factory, and then again token, so that we can have instance of our smart. Then we will deploy our smart. So these are the steps that we have done before also. I hope you remember them. Wait and token dot, and now we will transfer some tokens from owner's account to, let's say, address one. Okay, hard hat token dot transfer. So we are going to use a transfer function that is present in our token dot solve. Okay, and in this we will give the address of the person to whom we want to transfer tokens, address, and then let's say I want to transfer 10 tokens to this address. Okay, to this address one dot address. Okay, and now we will check whether it has properly worked or not. Right, await hard hat token dot balance of address one dot address. So what we are doing is we are actually checking whether the address one has received 10 tokens or not. So we will do dot to equal and then 10, and then we will have a wait hard hat token dot connect address one dot transfer, and then we will have our address 2 dot address. Now what we are doing is we are actually transferring from address 1 to address 2. Now you might be thinking like in this on this line we haven't done this like this, right? We haven't written like we are transferring from owner's address to some address 1. We have simply written this line and the transfer was being done from owner's address to this address 1. The reason for this is because hard hat by default understood, okay, since you have this owner, someone is actually deploying this smart contract, and this is this owner who is actually deploying this smart contract. So by default, hard hat know, okay, this address, the transfer that is being done from at this line is actually being done from this owner address only. So that's why we do not need to mention whether this transfer is being done by owner or not. So this is the by default behavior of hard hat. Okay, but definitely you can write like this also if you want that you want to have this await hard hat dot connect then owner's address to dot transfer address to dot address. So you can have like this also. Okay, and let's transfer 5 tokens. Okay, so owner transferred 10 tokens to address 1, and now address 1 is actually transferring 5 tokens to address 2. Okay, and then we will have our expect, and this will check whether await hard hat token dot balance of address 2, in this case address 2 dot equal 5 or not. Okay, we'll check that whether the address 2 has received 5 tokens or not. In this case, again I will say 10 tokens was transferred to address 1, and now address 1 has transferred 5 tokens to this address 2. Now let us test our smart contract. Write hard hat npx hard hat test, and let's see. Okay, again I think oh yes, this is the thing. Just remember that there should be no ether module inside your test.js, otherwise it will not work. Okay, let's again try this. Okay, wonderful. So now you can see that both of our test cases just passed, right? So this is the first test case, that deployment should assign the total supply of the tokens to the owner. That is this test case, right? And now we have the another test case, that is should transfer tokens between accounts, and that's why we have a 2 passing as number. But definitely if we will make some changes here, let's say I'm checking against 50. Let's see what will happen now. Let's try once again and let's see what will be the error. And now here you can see that we have an assertion error, that expected was 5. At this point we were expecting 5, but not actually. At this point we were expecting 5, but we have 50, and that is the error. I hope you understood how this testing is actually working in hard hat. Okay, and let us make it right so that we can end on a good note. But definitely this testing is not over. We will test this smart contract more thoroughly in the next video. So meet you soon in the next video. So in the previous video we have seen how to test our token contract, right? Now in this video, we are going to make some changes to our test file. If you will see our test file, you can see that we have a lot of repetition of code. Like for example, we have this token line being repeated. We have this get signers line being repeated. So we have a lot of repetition in our test file, and repetition is not a good thing, right? When we code, we do not want repeated code because it will increase the length of our file and it will not look good. So we are going to make some changes to our test file. And before that, we have to learn some concept related to before each hook that is provided by our Mocha framework. Because what we are doing is, what we are using here is Mocha framework, right? We have this describe, we have this it, and then it, and all of these are the part of Mocha framework. Now we are going to make some changes to this test file. And in order to do that, first of all, we have to erase all of these things. I know you must be thinking like, oh my God, we have done so much effort and now we have to erase all of these things. Yes, we have to erase all of these things. And now let us learn a concept related to before each hook. So first of all, let me use describe. And in describe, let me have our token contract. Okay, contract. Then again, we have our function. And inside this function, we are going to use our before each hook. Okay, so we will have our async function here because we are going to deal with promises. And now inside this async function, we will console.log before each, so that we can understand one concept related to before each statement, so that when we are rewriting our test file, you do not get confused like how this before each hook is actually working. Okay, so like this. And inside this describe block, we are going to have again one more describe block. Okay, again we are going to have one more describe block. And in this, let me write down as inside describe one. Okay, so that we have a idea inside which describe block we are actually working for. And all these things I am doing just to make you understand the concept related to before each hook. Okay, let me have our it block, and inside it we will have let me write first it. Then we will have our async function, and inside our async function we are going to print console.log 1. Okay, console.log 1. In the same way, I'm going to again copy this down and I'm going to paste it here. Let me write second it, and in this I will have 2. And let me copy this whole describe block so we can do all these type of stuffs. Okay, in this we will have our second, and this will be our third, and this will be our fourth it block, right? Third, and let it be fourth. Let me save it down. Let me have our terminal open. Now inside our terminal, what we are going to do is we are going to write npx hard hat test, so that we can see how this whole test file is actually working, how this before each hook is actually working. Okay, and now we have our test cases ready. Now we can see that first of all, we have this line token contract that is actually written in our this line. This is the first describe block, inside which we have two describe blocks, and inside this describe block we have this two it blocks, right? So let us see. So first of all, we have this token contract inside describe one. So now we are inside describe one, and inside describe one we have this before each running this console.log, means this before each is actually being printed because of this before each hook, because we have actually console.log this before each, right? And then we have this it statement, that's why we have been printed at console.log 1. Then this is our first it, then before each again we have second, and this is our second it. And then we have inside describe 2. Now we are inside describe 2. Okay, see describe 2. So this is our describe 2, and then we have our before each, then we have this console.log, and then we have this third it, and then before each 4 and fourth it. Now you must be thinking like why we are actually doing all these stuffs. So we are doing all these stuffs because to understand the concept of before each is very important, because we are going to use the same exact format in our upcoming test file. So it is very important to understand how this before each hook is actually working. So you can see that whatever line or whatever statement we have inside our before each hook, this statement is getting executed before each of the it block. That's why before each, then we have this 1. Before each, then we have this 2. Then we have this before each, then we have this 3, and then before each, and then we have this 4. And another important point here is to notice how we have multiple describe block inside one describe block. Like we have this describe block and this describe block inside our token contract. We have multiple it blocks inside one describe block, like this and this. And inside this describe 2, we have this it block and this it block. Now, why do we do such a thing? So that we can have a more readable type of test file. Like this will make our test file more readable in nature. Definitely you can have multiple lit blocks inside this describe block only. Like you do not need to have this describe and then this describe to use these multiple lit blocks. You can use each like one or like all these 8 block inside one describe block only. But this will not make our this test file more clearer in nature, because when we are going to test our test file, like when we are going to test our smart contract, and let's say your smart contract consists of thousands of lines, then it will be more difficult to read these test cases. And that's why we have these multiple describe multiple it blocks like of structure in our test file. So now we have understood how this before each hook actually works, and how we can have multiple describe blocks, multiple it blocks inside one describe block only. So now let's move towards testing of our smart contract. So first of all, let us remove all of these things because we do not require it now. Now we will start with our testing of our smart contract. Okay. So first of all, we are going to write describe. Inside our describe, we are going to have our token contract, and then we will have our function. And now we are going to create some variables. Like for example, token, hard hat token, hard hat token. We are going to use all these variables in our test cases. And then we will have our owner, and then we will have our address 1, address 2, and then address S. You will understand why we are doing this. Now we will have our before each hook, async function. Okay, now inside our before each hook, we are going to have our token contract instance. Like we will first of all create the instance of our token contract, get contract factory token, right? And then we will have our addresses inside our owner, address 1. We are actually using destructuring, address 2, and then we will have our address stick await dot get signers, because get signer will provide us with the different addresses that we require. And then we will have our hard hat token wait token dot deploy. Okay, so now we do not have to repeat all these lines when we are using different it blocks and different describe blocks. Okay, so now we will have this before each block, so this will execute all these lines before each of the 8 blocks that we are going to write. So our first describe block will be related to our deployment. Now inside this describe block, we are going to have our 8 block, which will actually test or check actually the right owner. Okay, async in function, and in this we will have our expect await hard hat token dot owner dot equal to owner dot address. So first of all, we are checking the owner of the contract, whether it is the actually the owner of the like owner address is actually the owner of the contract or not. Okay, and then we will have another 8 block. Now this will be checking should assign the total supply. Okay, so this will be checking for the total supply of tokens to the owner. Async function, and then this we will have our owner balance, since we are checking for the total supply, right? Owner balance await hard hat token dot balance of, we are going to use the balance of function that is actually present in our token contract owner address. So what we are doing is we are actually checking the balance of our owner. Okay, and then we are going to compare it await hard hat token dot total supply. So the owner balance must be equal to the total supply, right? And we can check that in our smart contract also. First of all, write this down. Equal owner balance. So let us check this in our token.sol. Inside our token.sol, if you will see, we have this constructor. So what we are doing inside this constructor, whosoever will deploy this smart contract, we are actually transferring the total supply to his or her address, right? So in this case, it will be the owner of the contract. And that's what we are actually checking inside this it block. And if you will see the simplicity of this smart contract, right, we do not have to repeat all these lines again and again. We have just written this inside our before each block, and now we can use all these lines inside our it blocks, right? And this is what the beauty of before each hook. So this will avoid, like this is actually helping us to avoid repetition of code. But the work is still not over. First of all, let me save this down. Let us check this whether it is working right or not. that if there are some mistake, we can rectify it down here above. So now you can see that we have some extras. We just move those dependencies. Let's see whether it is working the right way or not. Okay, so now we do have some error. Okay, I made some mistake. I think get track factory, right? It again. So now you can see that both of the test cases are actually passing. Okay, but the work is still not over. We have to have some more describe block and some more it blocks. So now we will have a describe block for checking the transaction. Okay, whether our transfer function is working correctly or not. So for that, we will have our transaction type block. We will have our function, and inside this, we will have our it block, and this will check should transfer tokens between accounts. Then we will have our async. So first of all, we are going to transfer some tokens from our owner's address to some address 1. Okay, because currently all the total supply is actually in the owner's address only, right? So we will transfer from owner address to address 1. Let's say we want to transfer 10 tokens. Okay, and now we will have our address of our 1. We will have the balance of our address 1, so that we can see whether the transfer has actually been taken place or not. Wait, hard hat token, but token balance of address 1, right? Address 1 dot address. Now we will use our expect statement to check the address 1 balance, whether this balance is equal to the mistake address 1, address 1 here also, and whether it is equal to 10 or not, because the owner has actually transferred 10 tokens to our address 1, right? So the expect statement should work and should be equal, like means address 1 balance must contain 10 because the transfer has been of 10 tokens from owner address to address 1. Let me write here also, owner to address 1 10. Now we will check for another transfer, that is from address 1 to address 2. Okay, dot connect address 1 dot transfer. So now the address 1 is actually transferring, let's say, dot address 5 tokens. Okay, so let's say address 2, like address 1 is actually transferring 5 tokens to address 2. Again, we will have the const. Let me actually copy these 2 lines. We'll have this, paste it here. Let's make it address 2, and let me make address 2. So now the address 2 balance must be equal to what? It should be equal to 5, right? Because address 1 has transferred 5 tokens. Here address 1 to address 2, how much tokens? 5 tokens, right? So that should be the case. Now let us make one more test block to check whether the not enough tokens required statement is working properly or not. Let's say address 1 transferred address 2 100 tokens, but let's say address 1 do not have 100 tokens. In that case, it should print not enough tokens, right? So what we will be doing, we will create another test block so that we can check for this required statement, whether this is actually working in a correct way or not. Now, in order to do that, what we are going to do is we are going to have our it block. Inside our it block, we will check should fail. It should fail if sender does not have enough tokens. Okay, let's say the sender does not have enough tokens. In that case, it must fail, right? Function. So first of all, we will have the initial balance, initial owner balance. Let's say owner balance, await hard hat token dot balance of owner dot address. Okay, and then we will have our await check expect that hard hat token dot connect address 1. You'll understand what actually we are trying to do. So owner address dot address, let's say 10 tokens. Okay, so what we are trying to do is we are actually trying to transfer 10 tokens from address 1 to address means to this owner address, and 10 tokens means like we are trying to do is transferring address 1 to owner address 10 tokens. Okay, so this is what we are trying to do. But if you will see here, So this statement should be false, right? This statement should be false. Now why? Because if you will see, what we are using is a before each block, right? So this before each block will redeploy this smart contract, means this redeployment of smart contract will take place, means initially address one will have 0 tokens, because at the start of our contract, if you will see, all the total supply of the tokens is actually being transferred to our owner's address only, right? To this owner's address only, means currently address one or any other address currently have 0 tokens, right? So in this case it must fail, means await expect hard at dot connect address ones, means the transfer from address one to owner's address 10 tokens must fail, right? And if it is failing, what we will do, we will revert it back to be, and I will be sharing some documentation with you so that you can also check all these test cases, like how and what we do when we have situation like of this required statement. Okay, so now to deal with this required statement, we can write here, actually we have to copy paste this exact line, remember to copy this exact line and paste it here. So what is actually doing is, it is saying, like, if this is failing, right, if this thing is actually failing, if this is like this test case is actually failing this line, then you should revert it with a statement not enough tokens that is actually present in our require statement, right? So if this line is passing, then we are going to this line, right? But if this line is failing, means if the balance of the sender is not enough to transfer some tokens, in that case we should have this line that not enough tokens. And now we will check the balance of our owner's address, and that owner's address balance must be equal to the initial owner balance, right? Because no transfer has been taken place from address 1 to owner's address, because address 1 does not have enough tokens. Balance, okay, actually it should be hard hat token, right? Hard hat token balance of owner address, owner dot address dot to dot equal, and then our initial owner balance. Let me save it. Now let me tell you what actually we are trying to do here. So what we are trying to do is, like, we are saying that since no token transfer has been taken place, right? No token transfer has been taken place from address 1 to owner's address. In that case, the initial balance, the initial owner balance, like before this transfer and after this transfer, should be the same, right? That's what we are checking for. Okay, so this is what we are trying to do here. Now let us test our test file. Okay, px hard hat test. First of all, check whether we do have, okay, we do have some extra dependencies. Just remove those extra dependencies. And now let us check our smart contract test file. Wonderful. So now here you can see that all of our test cases are actually being passed. So under deployment, we have these two test cases which are actually getting passed. Under transaction, we have these two test cases which are actually getting passed. So this is how we do testing in our hard hat, or actually I will say, how do we do testing using hard hat. So this is how we do testing of our smart contract using hard hat. So I hope you enjoyed this video. Meet you soon in the next video.